Good morning, good afternoon now, and welcome to the 8th Histelcon conference, the History of Electrotechnology Conference 2023 that is held this year in Italy and particularly here in Florence. I am one of the two chairs, you can see, and I just take you very few minutes to introduce the conference. So when we accepted the challenge to organize here the conference, we were a little worried on how to face the duty of attracting adequate number of delegates to participate in the conference. The strategies that we outlined was to extend the contribution behind the limits of, strictly speaking, electrotechnology. We open to contribution in physics, fundamental science, and also to humanistic studies in the field of technological history. And at the end, I must say that now we are really satisfied with what we obtained. You will assist 87 presentations. 6 of these are invited and will be given this afternoon. 76 are regular contributions selected after double review from blind reviewers. And 5, lastly, are contribution will be given in the panel on women in engineering that we attended tomorrow morning. So these results are really satisfactory for us. We had to reject some of the proposals which are not adequate to the conference. We have also accepted very little withdrawn from people who were accepted but could not attend and had to decline. And the final number are what I said. I do not take you more time than this. I leave the floor to Professor Lippi, who will give salutation from the rector of the university, and to move, I hope, quickly to the presentation after all the other salutation. So, thank you, and please.
Well, good evening to everybody. I am Donatella Lippi. I'm the president of the Fondazione Scienza e Tecnica, Science and Technique Foundation, and our group of research tomorrow evening will present a contribution regarding a case study of an Egyptian cat mummy. But now I'm here to welcome all of you on behalf of the Fondazione Scienza e Tecnica. And I'm also very proud to bring you the greetings of the magnificent rector of the University of Florence, Professoressa Alessandra Petrucci, who has asked me to share with you her appreciation for this initiative and her best wishes for a fruitful work. The aims of the Fondazione Scienza e Tecnica largely correspond to those of this Congress, aiming at the protection and the improvement of the instruments regarding the history of science and technology of the second half of the 19th century. And I personally, I am not a technician, I am a humanist, and I really appreciated the fact that museums and history and humanities were included among the topics of this Congress, because I think that these aspects are an integral part of a broad and transversal research which has a great educational value. Because only the encounter between these two worlds, science and technique on one side and humanities on the other, can bring concrete and fruitful results, benefits to humankind. In addition, I am pleased that space is given to the memory of Paolo Brenni, to whose knowledge and skills we owe the restoration of the physics collection of our foundation. And Anna Giatti, who works for the Foundation Science and Technique, will remember him later. So I thank all of you for being here, and I wish you good work and also a pleasant stay in this sunny Florence. Thank you so much.
Ladies and gentlemen, good afternoon. It is really a pleasure and an honor to be here with you today to this opening of the conference. This is an important opportunity, not only for gathering together and better understanding from the history what we can do for advancing technology, but it's also an opportunity for sharing our knowledge and expand our network and make more friends in the area. Thank you. Basically, what I would like briefly to introduce IEEE for the one of you who are not involved in this association and are not aware about this association. You may know that this is the leading international association in the field of electronics, electrical area, power, computing, and many other technological areas related to this, which spanned out from this original route. And we have covering the world with many global and local communities, focusing on different technologies, on different areas, and on different geographical areas. We are publishing over 190 journals, which are ranked among the top in the engineering area. And we are organizing about 2,000 conferences, including also the local conferences, not only the international ones like this. And we have really a huge library with all papers that have been published on technologies in the last decades. Region 8, which is the region in which we are today, is historically the organizer of this event, and you will hear about the future for this conference soon. Region 8 is one of the larger regions in which the IEEE is divided. We have about 80,000 members, and is definitely the most diverse and geographically large area, since it's spanning from Greenland to the Siberia, from Norway down to South Africa. So it's very diverse. I would like also to take this opportunity to point out how history is actually important, not only to remember the past, but also to attract the attention of for the future. In particular, I would like to point you out that IEEE is working, already launched successfully, the IEEE REACH program, which is exactly to use the history to promote education in STEM, to attract many more people to STEM, and as a consequence, to ensure that globally we grow much better, and we can ensure that we continue to be as diverse as possible. The history is important since we base our knowledge on the history of the discoveries of the past, but these bases are a stimulus, should be always a stimulus for the future. This is why I personally believe, and I bring this opinion also from the board of directors of the IEEE to you. I believe that really this meeting is important since not only celebrate the past, but open the door for the future and stimulate the attention to the future. From the bottom of my heart, thank you to the organizers, thank you to you for being here, to all authors, since this is really the opportunity to start building a better future for humanity, for the environment, and for all living beings. Thank you.
Per andare avanti? Okay. Good afternoon, everybody. It's my pleasure to welcome you in Florence, in Italy. I am the Region 8 Conference Committee Chair, and I would like to show you some statistics about the conference in the IEEE. As been said, every year around 2,000 conferences are organized in IEEE. And in Region 8, in the last 10 years, you see, we organized more than 7,000 conferences in the Region 8. And you see in one of the graphics the top 10 countries where these conferences are held. Italy is the first place because everybody likes Italy, not only the story, but the food, everything. So many people would like to come here and organize conferences here. And, but we have also the list on the bottom side, on the right, the list of the 10 sections that are more active in organizing IEEE conference in Region 8, and we have Tunisia, Italy, Czechoslovakia, Ukraine, France, and so on. And 20% of the conferences are technically co-sponsored by Region 8 sections. The other are organized by IEEE societies or other IEEE organizational units. And only 9% are financially co-sponsored by the section. And in Region 8, in the 10 years, we organized, like region, technical co-sponsor or financial co-sponsor, 130 conferences. These are just for saying some numbers. Some of these conferences are flagship conferences. We have 4 of them. Eurocon is the oldest, is always organized in the European part of the Region 8, and is organized every 2 years in the odd years. Then we have Africon, organized always in Africa, Melecon, organized in the Mediterranean countries, and Energicon, that is the youngest, that is only devoted to the energy field of technology. Eurocon, Africon, and Melecon has a larger field of interest covering all IEEE topics. And in spite of these 4 flagships, in our portfolio, we have other 3 conferences. ATSI, that is organized 7 times in Italy, but now was introduced between the portfolio of Region 8 conferences because it's the only one devoted with the focus on industry. So with a strong industry participation in the event. And the next edition will be organized in Italy because every 3 years, because we are the starter of the conference, every 3 years will be organized in Italy. In 2024 will be in Milano. IHTC is an International Humanitarian Technology Conference, which is based on the United Nations Sustainable Development Goals, so it's very interesting also for climate change topics. This one is a multi-regional conference, another model. This conference is rotating between 3 regions, Region 7, Region 8, and Region 9. This year is in Colombia, in Region 9, and the next year, next edition, 2024, will be in Italy, in Bari. And now, Histelcon, our favorite conference, the only one in IEEE devoted to history of technology. For this reason, this is the future of Histelcon. We are moving or transforming this conference in a multi-regional conference. probably including all IEEE, because it's the only one, always with the technical support of History Committee of IEEE and the History Center of IEEE. And we already agreed among 4 regions, Region 7, 8, 9, and 10, to rotate this conference among these 4, but the roadmap will be to include more on that. The 2026 edition will start with the annual edition of this conference, not only every 2 years, and from there we will become a real IEEE historical dedicated event. That is the good news for all the attendants of this important meeting. Thank you, and enjoy the conference.
Dove clicco? Qui? No, rodellino. Okay. Good afternoon. My name is Sergio Rapuano. I'm the past chair. Is it working? Okay. Past chair of the Italy section. I'm proud and happy to be with you this afternoon. Proud because the current chair, Professor Gianfranco Chicco, chose me to present to you the greetings of the Italy section and to welcome you to Florence on behalf of him that he could not attend. And happy because I used to be chair when the organizational work of this conference started, and I'm now happy to share with you the results of the effort of the organizers, who I thank along with the others. A few words about the section. No? Oh. Sorry. Okay, la fece meglio. This section was one of the first to be funded in the Region 8, as Martin said this morning. It was funded in 1959, and now we are among the largest. We were reinstated in 2005 by merging 2 existing branches, Northern Italy and Central and South, and now we have about 5,700 members, which classify us as a large section according to the IEEE standards. We are in particular very proud to have 1,500 more or less students and 2,500 young professionals. And we are very proud to have a very active life member group. The officers currently in charge are in this slide. Professor Chicco is the chair, Professor Gruoso is the vice chair, and then Professor Proto is secretary, and you have already met Professor Placidi, who is our treasurer and who will be with us all the time. The technical activities are carried out by 41 chapters, which is a quite big number, especially considering that many of them are very active. We have 31 society chapters, 5 council chapters, and 5 joint chapters. And of course, we have three very active affinity groups, life members, young professional, and women in engineering. In this time, I would like to take this opportunity to especially thank the life members group that are the backbone of the History Activity Committee that brought to the section a lot of outstanding results in the last years, starting from this conference and the series of history notes that you can have for free outside, and a boost, very high boost, in milestone dedications that are now are 9 in the Italy section. What the section does and what we do especially, mainly interdisciplinary events. Technical events are usually organized by societies and chapters. We are thinking to broaden the way of looking at technology and organize by technically or financially sponsoring interdisciplinary events. We support the organization of the affinity group events. We organize milestone dedications. We have a very diversified awards program to recognize our volunteers in their efforts. And we have our own distinguished lecturer program that we call Industry Distinguished Lecturer Program. And of course, we support the distinguished lecture travels from the societies. We, of course, support the organization of PhD summer schools, and we have our own PhD summer school organized every year in July in Brixton. Speaking of events, as Tiziana said, Italy is a very attractive venue, so we organized about 300 events only in 2022. We funded a new Region 8 portfolio conference, the RTSI, she already mentioned, and we have been organizing 3 Region 8 flagship conferences and 2 portfolio conferences in a few years. All these activities have been recognized by the IEEE by some awards. In particular, I would highlight the Outstanding Section Membership Recruitment Performance Award achieved in 2018 and 2021, and the Outstanding Large Section Award that identified us as the best large section worldwide in 2023. Thank you for giving me this opportunity, and I wish you to enjoy this conference. Thank you.
Antonio, it's your turn now.
Thank you. Can you hear me?
Yes.
Okay. Thank you. Thank you and good afternoon. As the chair of the steering committee of the conference, I would like to express a few words of welcome. I had the chance of attending the first Histelcon in Paris, organized by Region 8 of IEEE, and then I attended almost all of the following conferences. In 2012, I was honored and delighted to host the third Histelcon in Pavia, where the new Museum of Electrical Technology had just opened. In this connection, I cannot forget the generous support I then received by Jacob Baal-Shem, the promoter of the first Histelcon, a true IEEE ambassador, very active in Region 8, and not only. He passed away a few years ago. During the past 15 years, Histelcon grew up, collecting attention well beyond Region 8. And now, as has already been reported, and now I think that it is time to recognize that it has become a multi-regional IEEE conference, or the IEEE Conference on the History of Electrical Technology. As the current chair of the IEEE History Committee, I can confirm that the IEEE History Committee is pleased to offer full technical sponsorship to the conference. It is not meaningless, by the way, that just yesterday, the IEEE History Committee had a meeting here. Let me end up my expression of thanks to all the authors of contributions, to the institutions supporting the initiative, to the organizers who have worked and are working for the success of it, and especially to Giuseppe Pelosi and Stefano Selleri, life and senior members of IEEE, respectively, well appreciated scholars of history of technology and restless proposers of initiatives. It is their merit to have planned for us this conference, which I'm sure will become memorable. Thank you very much.
Good evening, everyone, and you have my welcome to Florence too. I will show you a few hints about the technical program as fast as I can because we are already lagging behind our schedule. Thank you. You already have been told about Histelcon history and where previous Histelcon had place, while our current history, from an idea from the two co-chair Massimo Guarnieri and Giuseppe Pelosi, was to think about the link between science, pure science, and technology, since new scientific discoveries allow new technologies, but also technologies can build better instruments and hence lead to new scientific discoveries. This is a virtuous circle which we hope will be highlighted in some of the sessions which we'll have tomorrow. The technical program, as you know, it starts today with a keynote session which will start in a few minutes here. It's not the Aula Magna, as all of you know. We are in the Red Room. We had the chance of having a big aqueduct loss, water loss inside the rectorate, and we had the chance to have this room, which is nice too. Tomorrow we will be in the Antica Canonica of San Giovanni. Okay, this is the place we are not now. I haven't got the photo of this place because it's we just discovered at 10 o'clock in the morning where we will have a keynote speak session. The keynote speak session has 6 very important and interesting papers you will discover very soon. While tomorrow we will rejoin in the Antica Canonica in San Giovanni. The entrance is very, very inconspicuous. It's not easy to find it. It's just in front of a baptistry, and since it's dedicated to St. John, you can recognize it for the baby St. John here. You should look for the baby St. John. Enter there. There is a short corridor, a ticket office which is not meant for you, and in the end there are stairs going up to the conference center. Well, I won't give any time about the technical session. You have a program online, but I remember you the social dinner. Please confirm if you will be present or not at the reception. And you will be free on lunches. You can go eating wherever you want. There's plenty of places in 100 circle radius around the conference center. We will have coffee breaks, of course. The social dinner will be in Via de' Bardi, just across the river. It's a few hundred meters from the conference center. And we will end with technical session on Saturday morning, and of course some final consideration there. For what concerns the technical part of the contributions, we have 152 authors for the 87 papers remembered by Massimo. This comes from 23 countries, nearly 1/2 from Italy. Then there are a lot of Russians, German, and United States, and lesser contribution by other countries. The technical session we are divided in 8-9 technical sessions, plus the Women in Engineering Affinity Group panel discussion. And sadly, we had a couple of papers which were withdrawn. As you know, the Histelcon allowed both abstracts or full paper submission. The percentage is 43% abstracts and 57% full papers. Of these 48 full papers, a selection, those having a full positive score by the reviewers, will be submitted to Histelcon. For the rest of the logistics, well, now we are somewhere here, actually. The main conference center is just in front of the baptistry, as I told before, while the social dinner will take place here. I remember you that you have a free access to the Instrument Collection Museum, just showing your badge. So please visit it. It's full of very interesting instruments, and Donatella Lippi reminded you of this before. Okay, this is all for me now. We should go on with the technical session, with a full keynote session. Questa, secondo me non c'è bisogno di far vedere le persone uno per uno, le chiamiamo. Actually, this plenary section was meant to be chaired by Professor Bucci, Ovidio, not Giacomo. Professor Bucci sadly has some health problems, so he won't be able to chair this session. I will try to chair it as good as I can. So please, the first speaker is Professor Grandin from Stockholm Academy of Science, please.
Thank you. Well, I thought I should stand there, but the microphone is here, so here I am. This talk, thank you very much for the invitation. I should start with that, of course. I will not talk about Owen Richardson, the kind of scientific work he did as much, or anything about, as all of you know, about the patent disputes and litigations in this whole field at the time. What I'm interested in is in the Nobel Prizes. Yes. Unfortunately, we all know that Richardson was awarded the 1928 Nobel Prize in Physics in 1929. And he came to Stockholm and gave his Nobel lecture. And if you look it up, you can, his lecture was on the thermionic phenomena and the laws which govern them. And it was illustrated by lantern slides.
Could you speak to the back of the room? The microphone is not picking you up. Just speak more loud.
I'll try like that. Does it sound better, or?
You can have to sit down.
I can sit down, yes. Sorry for that. So, well, he used the lantern slides. Unfortunately, I don't know or have seen these lantern slides. Anyone who has, please let me know. So you have to put up with my lantern slides for this lecture. But before the lantern slides, there were, of course, a decision. And here you see, and now you can practice your Swedish, you see the minutes of the Academy when they make the final decision. But you can also, even if you don't understand Swedish, you can tell that it's a very short text. It says, the Royal Swedish Academy of Sciences decided to award the Professor Owen Willans Richardson, London, 1928 year Nobel Prize for Physics. So that is one problem if you should do research into the Nobel archives. It's decision minutes, it's not discussion minutes. And the heated discussion is not in the community of scientists or engineers. The heated discussion is within the Nobel Committee. We also were still at the end of this story. He telegraphed to the Academy that he would arrive with his wife and their daughter. But from my original title, why from nobile? Why nobile? Most people here knows, of course, of the story of the At first, very successful attempt to go to the North Pole with the balloon airship, but the return trip was ill-fated, and a lot of events, rescue attempts didn't go that well. But you will have to wait a bit for the connection with Noble, but I just asked the question right now. This is from my hometown. It's actually not now. It's a bit cooler in Uppsala, Sweden, where I live, than here. But this particular, it's of Finn Malmgren, one of the people going on this Arctic trip with Noble. He didn't survive. He was on the part that tried to get help and were lost somewhere on the ice sheet. But I have a friend who always said, let's meet up at the astronaut. So she always considered this an astronaut. She didn't know the story. So it's good that you know the story. But my point here by using this image is that perhaps the Arctic explorers at the time were considered to be as the astronauts are in our present time. So, but then we should do also one backtracking. We should do the Nobel 101, some basic understanding of how the Nobel Prize system work. This is how it looks in Stockholm in December, indoors at least. A lot of pomp and circumstance, but international, of course, it's when the awards are disclosed nowadays in October, previous through history in November, and even in December earlier years are announced. Everyone knows that Alfred Nobel is the donor, great donor, who donated a large sum of money for these prizes. And the will, of course, his will is then, of course, important. But what really governs the prizes and how it works are the statues that had to be sort of invented based on the will of Alfred Nobel, of course. And the statues are for the Nobel Foundation and for the Nobel awarding institutions. And these are the Nobel organizations. Physics and chemistry is the Royal Swedish Academy of Sciences, and then you see the rest, and they form together the Nobel Foundation. Nowhere in the will of Alfred Nobel it says the Nobel Foundation, so that was an invention made by the prize awarding institutions. The Nobel Foundation runs the finances and festivities and public relations and stuff like that. Now we're getting a bit closer into the more important stuff. Prize awarding institutions. Who are doing the most important work? It's the Nobel Committee. And in physics and chemistry, it's 2 different committees. There is 1 chairman and 4 members. And this was, so these 5 people, 5 persons, 5 physicists are crucial to understand and what were their thoughts about this and how they try to solve their problem of awarding such a prize every year. You need to have a valid nomination. You can't apply for the prize. That was one idea they thought of at first before they settled for the statues, but that you should have a system where you ask different categories to nominate. If you can read this up here, I would say that paragraph 3, Nobel laureates in physics, are of course very important. Not all nominations are created equal. Of course, some people have a greater weight. But most important was, of course, perhaps paragraph 5, where the Swedish Academy sent out invitations every year to all over the world to ask for nominations. More often to the bigger universities and stuff like that, but early on still sent out to different kind of parts of the world. This is a work that runs all the year round. This is how it looks these days. But you could at least the take-home message is that it's an operation that runs. Actually, the Nobel year is longer than a calendar year. It actually starts in September and ends in December and last year. And of course, if you go into the Nobel archives, the interesting thing with the Nobel archives, I don't know almost any other prize out there where you could look into the archives. Prize awarding is something that we would like to keep a bit secret, and so on. But a bit strange that this prize has such a great prestige. In 1974, it was decided that one should be able to do historical research with a 50 years back at least. And so then these volumes, of course, they were not created for us historians. They were created for the work themselves within the committee. So if you read, if you can understand my arrows here, if you start a volume like this, you see here, it starts with the minutes and then the class meetings of the physics and chemistry class, the general report from the Nobel Committee, and then the special reports on the most interesting candidates, and then nominations. So you find all this, but of course, you read it in that way, but chronologically everything starts with the nominations and go on, so like that. Nominations, a nomination is needed. So then about Richardson, he must have had at least one nomination, but here we can see all the nominations he got. He had no nominations at all before 1924, only two in 1924-25 that was sort of disregarded, as we can see. But then in 1926, I already disclosed that perhaps not all nominations are the same. Niels Bohr, as you know, was an important figure, and he also had a great influence on Nobel decision, and he was very much revered by the Swedish physicists at the time, of course. Niels Bohr had the Nobel Prize himself in 1922. So he made a nomination of Richardson. Åsén, a Swedish theoretical physicist, a few years earlier, Åsén is the one who managed to get Einstein the Nobel Prize. We will hear more about Einstein later on, after a long period. But he wrote an 18-page special report on Richardson. In this report, he ended actually by sort of saying he dismissed it really on formal grounds. You have to understand, every year you have to make a decision. So, I mean, when you make evaluations yourself, you lift up the one you want to be awarded something or given a grant and play down everything else. There is a rhetorical element there. It's natural, you can say. And this goes at least especially into this material. So he dismissed it. It was too old. That is one of the aspects. It should be something more recent. And this is central to the rest of the story. But still, in the end, he said it wasn't not a definitive opinion of his. So we can see here, his 18-page report had these two sections that you can read there, into the emission of electrical charged particle by incandescent bodies, and also the photoelectric and the gyromagnetic effect. And also the quote there, that one of these investigations, the experimental proof of Maxwell's velocity distribution law, is of principal importance not only for the theory of the thermionic currents, but for the whole statistical mechanics. And this was sort of talking about that this is also important for basic science, not just technical stuff. But still, as you can read in the last section there, he concluded it's important for present electrotechnology, but too many contributors. That was also part. You know the story that there were so many people working on this field, so that was too old and too many contributors. We go to the next year, 1927. Svante Arrhenius, another Nobel laureate, the first Swedish Nobel laureate in 1903 in chemistry, but still he was a member of the Nobel Committee for Physics. Normally the members of the committee didn't nominate that often, but he was old at this time, but he nominated Richardson together with Fleming, added Fleming to this report. And Arrhenius' argument, as you can see here, was that the radio, which is indeed the most epoch-making invention of recent times, which to unusually high degree fulfills Nobel's prescription for the greatest benefit of mankind. But this year, unfortunately, Svante Arrhenius dies early in October. Another member of the physics class, not a member of the physics committee, Benedix, who was a professor of metallurgy, wanted to have his opinion taken to and writes a long 7-page letter to the whole of the physics class. And he starts with this field and talks about Richardson, and you see also about Edison, but there were no nomination. Fleming, 4 nominations this year, but De Forest, no nomination this year, and some other stuff. And he also uses the very same: contemporary cultural life is currently more obvious than the development of radio technology. And also, but Benedix really wanted to do some other stuff, but we will leave that aside for the time, for this time. So, and we go to 1928. Niels Bohr again nominates Richardson, together with Langmuir, if I remember correctly. Svante Arrhenius had died, so a new member of the Nobel Committee for Physics had been elected, and that was Henning Pleijel, who was a professor of theoretical electronics in Stockholm. He writes a 10-page report, not just on Richardson, but on Langmuir and Fleming that year. And he comes to the conclusion that Owen Richardson is indeed worthy of a Nobel Prize in physics. But he also adds, actually, that it is, if it's not too long ago that this was made, or that it was sort of became obvious that it was important. Sort of similar to what Osen, the other guy, mentioned in 26. So here we see these 5 men, as they were, of course, in those days of the Nobel Committee. You see, let's see if I can use this. Sigban, you probably know the name, X-ray spectroscopy, professor of physics in Uppsala at the time. Carl M. Gyllenskiöld, actually also been to the polar researcher. He was a professor of geophysics. Osen, the professor of theoretical physics, we can say, in Uppsala. And Pleijel, Henning Pleijel, electrotechnology, theoretical electronics. And this guy, I always say, it's Alvar Gullstrand. He almost got the Nobel Prize in physics. And this is strange because he was a professor at the University Hospital in Uppsala. He has gone down into history that he's the one who has opposed that there should be a Nobel Prize to Einstein for the theories of relativity. And that is another story, so to say. But when he got the Nobel Prize in medicine, he got up from his chair at the University Hospital, went over to the Physics Institute and said, I have been awarded a Nobel Prize, I will sit here. He wanted to be a physicist all his life, but wasn't allowed for his father. He should be something decent, like a medical professor. So if you have children who wants to be physicists, let them be there, because otherwise it will end badly. But also, who here would like to have an oral examination with this guy? I don't. He was an ophthalmologist. He was an expert of the optics of the eye. So, of course, he thought he could sort of figure out the theories of relativity and better than Einstein. So there is a lot of interesting debate between these 2 gentlemen. But that is another story. Sorry. But then we know these guys. And the committee made the decision in 1928 that by the majority vote that the 1928 year's Nobel Prize in Physics should be awarded to Richardson. Gullstrand is the chair. He's on top there. But you see there is something in brackets below that he makes a reservation or makes an objection to the decision. The other old man, Colin Gyllenskiöld, does the same. Osen does the same, but he tries to defend the decision. So there was a 3-2 majority in the committee for the decision. So that's why they made the decision. Then we go to the, that was the committee. Now we are with the class, the physics class. As I said, Gullstrand and Colin Gyllenskiöld made the formal objections. And now, finally, we get to the connection with my joke within the title, the noble argument Osen makes in a text to the physics class. I would also like to add for my personal part that the role that the radio played in the rescue of some of the members of the Nobel expedition was also important. And this is interesting, but it's even more interesting because Osen never made such arguments at the time. He were only very sort of basic science and never alluded to this. 8 votes for Richardson in the class, 3 against. They had joined the permanent secretary of the academy. And Osen claimed also that from 1926, when he had said Langmuir's contribution perhaps needs to be more evaluated, was now resolved, he claimed, and Richardson deserved an undivided Nobel Prize. However, the Academy voted to reserve the prize 1 year. They could always do that. And of course, that was a blow to Osen. But the Academy, the other members of the Academy thought, well, if the permanent secretary of the Academy, if the chair of the committee, 3 very senior professors are against it, we should perhaps be careful. And that was the result. So we have to go to 1929. What had happened was that there are other things happening at the same time. How are I for time? Yes, there are some time left. Yes, 5 minutes. Okay, I will make it, I think. 1929 is the year that he is awarded the reserve prize. So we know how it will end. So we can relax and we are not alarmed by this. Then again, Bohr makes a nomination, and also a combined nomination from Rutherford and Wilson mentions Richardson, so that is interesting. But strangely, there is no special report. I think this is one of the very, very few Nobel laureates who are awarded the Nobel Prize without having a special report the same year. But as we saw, there was one before and prior to that. So here is the Nobel Committee for Physics in 1929. Now you see that he is on the way out, and instead we have Erik Hultén, a new professor in physics in Stockholm. He was an expert on band spectra, from molecules. And we see this, how they sign this. But the schism in the committee continued. Of course, Gullstrand was now no longer a member of the committee. Colin Gyllenskiöld repeated their formal objections to the physics class. As you said, there is a decision there is a suggestion from the committee that goes to the class, physics class, and then to the academy. So, but they were the only ones who made this objection. As we saw, Gullstrand had been replaced by Erik Hultén, and he voted with Osen, Sigvard, and Pleyel. So now there were 7 votes for Richardson, 1 against in the class. I think Willem Colin Gyllenskiöld was not attending the meeting. Because at the same time, Osen wanted to get rid of Colin Gyllenskiöld because he was too old and he wanted a new, actually. Actually, he suggested that Niels Bohr, a Dane, should be on the committee, which didn't happen, but is interesting just to, if it was just a play by Osen or if it was really trying to do so, because they claim they need to have more understanding of the new, what happened in physics at the time, as we all know. And as already from the year before, the doubts were resolved, and Osen was a firm believer now that Richardson deserved an undivided Nobel Prize. Osen and Bohr were very close friends, we should say, already from 20 years back, we could say. Actually, it was Osen together with who helped Niels Bohr get the professorship in Copenhagen, but that is another story as well. Now, finally, the Academy voted according to the proposal of the committee that had been endorsed by the physics class, and the prize was awarded to Richardson. And this is how it looked at the time. If there is time, we can also play a slightly moving. But we should return again to this a bit strange argument that Osen gave the presentation speech in the hall that you saw before, and then I quoted this page. I should like to give another example of what was recently been attained in that department. On the 16th of February 1928, there was a conference between the American Institute of Electrical Engineers in New York and the Institution of Electrical Engineers in London. The various speeches could be heard in both places by means of loudspeakers. What we take for granted these days, but this was remarkable at the time, of course. Most people here present will certainly be able to recall to mind those anxious days when the news of the missing Nobel expedition was awaited all over the world. Everyone will no doubt remember that the first word of the lost expedition was picked up by a wireless amateur. I think that on this occasion it was clear to many people that wireless is not only a means of diversion, and as such one of the more prominent, but also one of the most valuable expedients in the struggle against that sort of nature which is still unconquered. We wouldn't praise it like that nowadays, I think. Every owner of a valve receiving set knows the importance of the valve in the apparatus. The valve, the essential part of which is glowing filament. So, and also another argument that they used was that they said that this electrotechnical advancement was important, for example, to control X-ray. And X-ray was, discovered earlier, but was also, it had benefits, but it also had downsides. And to be able to control the X-ray machines was important, which is also late argued in another section of this text. So I should stop. 2 minutes, okay. Is it possible to show the movie? It was among my slides. So the main purpose of my talk here was to give you a slight insight into the operations of the Nobel at the time. There is no sound to this, so I can continue to talk because it will just be an illustration. Yes, please. It will end. Those of you who will get the Nobel Prize in the future, you can learn how it's done here, so you know how to. It's a good exercise. But Richardson was sort of a nice candidate in this field, because I talked to you also about this, the Fleming and stuff like that. It was the same with Marconi, with the book you received here, that the Nobel system had problems. The Nobel system was very much geared to basic science. So Marconi, the solution was to have it together with a sort of ordinary physics professor at the university. And with Richardson, he was sort of the basic physicist, basic scientist. So it was an easier choice. And also, of course, it was very important that Richardson had the support from Niels Bohr over many years. There he goes up with his diploma and medal. And we can stop there, I think. So, thank you very much.
Thank you, Dr. Grandin. Actually, since this is a plenary talk with technical, if anyone has a question, please. Otherwise, we will move on the next speaker.
If you read Marconi's recommendation for Nobel Prize for Fleming,
Thank you. Just one quick question.
Just a question related to this conference that connects the science and technology and show the link between the two. Is there any running discussion about the Nobel in technology?
Well, there are many discussions. When I grew up, sorry, Louisa, almost all the prizes went to something that happened at CERN in the 80s. And that was, of course, for a good reason. But people ask, why is there no Nobel Prize in mathematics and so on? So there are all these differences. You know that there is an extra prize, the prize in economics, which is not a Nobel Prize. It's an debated thing. So actually now they have made the decision never to add any new associated prizes. That tells you something about how most people see the prize in economy, but that is another story. So there are other prizes. Start a new prize. But of course, this prize happened to have a long history and a lot of prestige, and a lot of the long row of laureates are adding to it, of course. So nothing, but there have been, you know, when it was integrated circuits was awarded, so sometimes they have tried to be a bit more. I think they are a bit more open than they were in the 1980s. That man has left the committee now.
Thank you again, Dr. Grandin. Our next speaker is Professor Luisa Cifarelli from the University of Bologna and INFN Bologna. Thank you.
Okay. So, again, thank you to the organizers and friends from Florence who have given me the opportunity to be here today. So, the title of the talk at this conference is Einstein Speaks Italian. No? Okay, it's a little bit slow. I should do it with this? Okay. So, since Einstein speaks Italian, is due to his family and to his life, just let me say a few words about the family. So he was born in Ulm in 1879. His father was a small entrepreneur called Hermann. His mother, Pauline Koch, was the daughter of a wealthy merchant, and she was a very concrete and active and clever woman. The family moved to Munich in 1880, and in 1881, and this is an important person in the story of Einstein speaking Italian, his sister Maria, called Maya in the family, was born. The thing I want to point out, which is related to Florence, and not only, is the question of the violin. In the Einstein family, the mother was a music lover, and she was a very good piano player. And so she grew the children, Albert and Maya, to play an instrument. And Albert was playing the violin since a very little boy, and Maya was playing the piano. And soon the violin became a passion for Albert as a teenager, and throughout his life, he had a lot of fun and a lot of nice times and moments with his violin. He was a fairly appreciated violin player. He was very passionate, and occasionally he was also a pianist, but not as good as a violin player. And he wrote in a letter in 1928, responding to some journalists asking him about music in his scientific activity, and he said, "Music does not influence research, but both derive from the same source of inspiration and complement each other in the sense of liberation they bring us." So I like this. And I must say his taste for composers was very classic. Bach, Mozart. He was very, let's say, conservative in this respect. These were his favorites. And the reason he wrote again was because the works of these composers were characterized by internal unity, harmonious architecture, and a sense of intimate necessity, like physical theories. So you see, he had a special sense for music. In 1885, aged 6, he attended the Peterschule in Munich, and in 1888, he started the gymnasium, the Luitpold Gymnasium in Munich. There's a lot of saying about the fact, fake news, about the fact that he was not good in mathematics, in scientific subjects. This is not true. He was very good. He was also good in Latin, Greek. And his uncle, Jacob, so the brother of his father, played a role in the attitude of Einstein, his interest of Einstein of Albert in science. So let's now come to the reason why the family is concerned with Italy. So in Munich, Hermann Einstein had, together with Jacob, who was more active, he was the author of several patents, had a small enterprise, a company for the production of electric dynamos and arc lamps. And the beginning, the firm was quite successful. They had hundreds of employees, but in 1894, fortunes turned, which is a way of saying, and the company went bankrupt. So they decided to move to Italy to find maybe better opportunities. So the Einsteins moved first to Milan, where they founded the Einstein Garrone and C company, and then to Pavia in 1895. Here's the building of where the firm was housed. But unfortunately, even this firm had to close. No success at all. Jacob returned to Germany, where he was rather successful in his business. Instead, Hermann settled in 1896 in Milan. And he was trying again some little activity in his domain, but none was successful. But anyway, he remained in Milan until he died in 1902. So as you see, the links of Einstein with Italy are due to his family. In 1894, Albert, who was quite rebel and independent with respect to the rigid German educational system, school system, decided on his own to leave Munich and join the family in Italy because he wanted there to study as an autodidact to try the admission to the Zurich Polytechnic. So he left and arrived to join the family. The family had moved to Pavia, as I told you. Pavia is close to Milan. And while he was in Pavia, he, due to the music, by the way, he became, together with Maya, friend of the family Marangoni, in particular of a nice young girl, Ernestina, with whom they were playing piano, violin. And the Villa Marangoni in Casteggio, which is nearby Pavia, on the other side of the River Po, Oltre Po Pavese, was, in 1895, really his favorite place. And all his life, he remembered the time he spent in Pavia and in Italy as the most beautiful memories of his life. Okay, so he studied in Pavia to try to be admitted at the Polytechnic of Zurich, and he failed. Well, he was 2 years ahead of time. So he decided to go back to school, and he went to Aarau, where he attended the Alte Kantonsschule, and finally he was admitted to the Polytechnic in Zurich in 1896. In Zurich, he gained 2 great friends of his whole life. One was studying at the Polytechnic, Marcel Grossmann, who was a mathematician, and the other one was a Swiss, Italian-Swiss engineer, who was his friend for all his life, called Michele Besso. During his staying in Arau, Einstein was mentored by a professor of classics who was plenty of things, he was also a poet, a journalist, quite an eclectic person, called Jost Winteler, a professor at this Kantonsschule where Einstein was catching over to be admitted at Zurich Polytechnic. And Jost Winteler had plenty of children. Einstein fell in love with one of the girls, but then this was over. The sister, another sister, married later on Michele Besso, and another son of Jost Winteler married Maya Einstein, who had also been studying in Arau, and in 1910 she married Paul Winteler. They moved to Florence, and they lived in Florence, nearby Sesto Fiorentino, again with plenty of musical activities. And this is a little anecdote. Einstein, Albert, offered as a present to Maya a very nice piano, a grand piano that he had been buying in secondhand, but it was a very valuable piano. And when Maya, together with Albert, had to leave for the United States, the piano remained in Florence under the care of a friend called Hans Joachim Stauder, who was living near Arcetri. And one of the sons of Stauder was an astrophysicist. And therefore, this is the reason why the piano offered by Albert to Maya is visible still at the Arcetri Observatory. So if you want to go and see the piano, it should be there. Now let's go back to Einstein. He graduated in Zurich in 1900, but he was very unhappy with his supervisor. So he didn't want to remain in Zurich, and he moved to Bern, thanks to Grossmann, who found him a job at the patent office. Now, of course, it is impossible to summarize in a few words all the achievements of Albert Einstein during these first years in Bern, where he had plenty of time to think, and he made some fundamental theoretical discoveries at that time. Let me just give the titles of these discoveries. Prior to his Nobel Prize, which was already mentioned in 1921. So in 1905, quantum theory of light with the interpretation of the photoelectric effect. The same year, atomic theory of matter with the interpretation of Brownian motion, and the same year, the theory of special relativity. So after these discoveries, he left Bern in 1909 and became a professor of theoretical physics at the University of Zurich and the director of the Kaiser Wilhelm Institute in Berlin, now Max Planck Institute in Berlin. And in 1915, so 10 years later, he formulated the theory of general relativity, which is really something absolutely admirable. Let me already mention here that at a certain point he was quite desperate because of the mathematical tools he needed for his theory, and it was again Grossmann who suggested to get in touch with two great Italian mathematicians, namely Tullio Levi-Civita and Gregorio Ricci Curpas. I'll come back to this. And of course, the theory of general relativity, mixing together topology, gravitation, space, was something absolutely fantastic. And Einstein became a superstar in the... Oops, sorry. Okay. No. How do I go back? Yes, okay. Fine, so now Bologna. Why Bologna comes into the game? Well, here you see a postcard of the Towers of Bologna, and it was a postcard that Einstein sent to Michele Besso, his friend, in 1921, saying, we are here with his sister Maya together in Florence. Tomorrow I'm leaving for Bologna, where I have to give a lecture in Italian. Poor guys, he writes. And of course, he had been learning Italian, as I told you, in his youth, but nevertheless. So the visit to Bologna was very, I think it's important because it was the only Italian city where Einstein gave lectures open to the public on relativity. So there were town lectures, not academic lectures, which is quite interesting. Why? He was invited by a famous mathematician, professor at the University of Bologna, called Federico Enriquez. I have this information from a book, which is now has been translated into English and will be published by Springer Nature. The book is called Einstein Parla Italiano, and it has been produced by two friends of mine from the University of Bologna, Sandra Lingueri and Raffaella Simili, historian of physics, who unfortunately passed away last year. And I want to pay a tribute to the memory of Raffaella, who was also a good friend of Carl Grandin. So Enriquez in 1920 wrote to Einstein because he had, of course, learned the success of the theories of Einstein on special relativity and general relativity. He writes, he confesses that he had not well assimilated the spirit of its guiding ideas, quite difficult, and wished to meet Einstein to have a favorable and restful conversation about it. The opportunity to meet Einstein came in 1921 because Enriquez was organizing a series of, a cycle of conferences, of science conferences open to the public, and of course he wished Einstein to inaugurate this series. And with the rhetoric of the time he was writing, no name has seemed equal to yours and no subject so exciting to the scientific world as relativity. So Einstein replied positively to the invitation. He was very happy, always remembering the beautiful years of Milan, Pavia, Casteggio of his youth. And Enriquez was so happy. And at the end of 1921, they moved to the organizing phase, and Enriquez was inviting him to lecture every second day in October of 1921. And what is nice, he was also writing in this way, since you have time in between the conferences. In this way, there will be an opportunity, as you kindly suggest, to arrange some meeting en petit comité, since many of us are anxious to have so many explanations from you, as you can well imagine. And in any case, please come to my house for tea on Friday evening, the 21st at 9 p.m. Okay, so this is the place, the Archigymnasium of the University of Bologna with the beautiful arcades, the loggias. This is a picture before the war when, unfortunately, it was bombed, but then rebuilt. And this is where, in a beautiful Aula Magna there, the lectures of Einstein were organized. There are only a few photographs of this event. The photos were taken, it seems, by the young son of Enriquez, called Giovanni, with a Kodak camera. And this is the most celebrated one. As you can see, this is Einstein on the left, discussing with Enriquez, and I like very much the silhouette of this picture. And this is also a fantastic picture. This is the professors of the University of Bologna of the time, and here you recognize Einstein in the middle. Then to the right, here is Enriquez. Oops. Enriquez here, and then all the others. Please notice the beards, the moustache, and of course the absence of any lady. And okay, At the meeting in Enrique's place, there were many journalists who came, and there was the reporter from the Corriere della Sera who reported about Professor Alberto Einstein. So they changed into Italian the name, Alberto Einstein. Professor Alberto Einstein arrived in Bologna today from Florence, and he met the best of the Bolognese intelligentsia. A few minutes after arriving, he had already engulfed himself in a discussion with two luminaries of Italian science, Tullio Levi-Civita and Quirino Majorana, one a very strong mathematician, the other a very strong physicist. And then, of course, there were many reports on the press, and they were also commenting the way Einstein was speaking Italian. According to the journalists, he was a very good Italian speaker. I don't know whether it was really true, but nevertheless, it was nice to read that he was in Italian, a good master, absolute and wealthy of our language. Okay. This is the aula where the lectures were taking place. They were crowded, packed of people, like a bel canto star on an opera stage. Everybody was there because they wanted to say, I have been there listening to Einstein. And also Enriquez was very emphatic in presenting Alberto Einstein. He does not need to be introduced. The fame that is in this case heralding glory has already called out his name. So this is the language of the time. And anyway, he was really emphasizing how the theory of relativity is so surprising and almost frightening in the progress it implies, that it is definitely beyond the limits of intuition. And of course, it's revolutionary, but in his introduction to Einstein, Enriquez was saying Einstein's theory does not mean the death of Newton's theory, but the conquest of a truer truth. So, I mean, the lectures where I'm not going to illustrate the theory because it's impossible, but of course, in the first lecture, Einstein started with special relativity, explaining that in reality it's the theory of invariance when you moved from one rest frame to the other, and that the laws of classical physics are not destroyed, simply they need corrections, and these corrections have an enormous impact, but however, when you are at low speeds, everything still holds true. In the second lecture, of course, he had to move to general relativity, and he had to imagine now that to explain that the frames were moving one with respect to the other in an accelerated way, and he was demonstrating that when the motion is accelerated, then the system is locally equivalent to a reference system subject to gravity, and this is how he introduces gravity, and he had to explain that due to the effect of gravity on the space-time doesn't remain flat, but it is curved by gravity, then light doesn't go straight anymore, but it has a bent path, and therefore this means that it was a total revolution, the effect of gravity on light. General relativity reduces to Newton's theory when gravity is weak. And this is what he explained, and in his third lecture, this is very interesting. First of all, he quoted the contribution of the Italian mathematicians, and this was, of course, the audience was very pleased. And then he illustrated the experimental confirmation that was obtained in 1919 when observations of of some given stars was made during a total eclipse, and compared to the observation of the same stars at night. Because clearly when the sun is nearby, then the effect of this huge mass, 300,000 times the mass of the Earth, on the light would become visible. So comparing night observation and during the eclipse. And to do so, there were two expeditions sent, one to Africa and the other one to Brazil from distinguished British observers. Okay, and so according to Einstein, this should have been the end of the controversy. In reality, it was not the case. Yes, it was not the case. And the controversy went on for years, and maybe there are still things to be understood at the level of the universe on these beautiful theories of gravitation. Now, he was made a member of the Accademia delle Scienze in Bologna. The first publication in Italian of the translation, of the paper of Einstein on special and general theory of relativity was made, of course, by Enriquez, who was a consultant of the publishing house Zanichelli, which is one of the most famous one in Italy. Notice that he is called Alberto Einstein, and the preface was by Tullio Levi-Civita, and it was published immediately after the lectures of Einstein. Let me add that in 1923, Enriquez again wrote to Einstein because he wanted to express the desire of the Italian Academy to have him as a professor in Italy. He had moved to from the University of Bologna to the University of Rome, and he knew members of the government, and in particular the minister Gentile, who was the Minister of Education. Why he wrote to Einstein? Because there were rumors about how difficult the situation was becoming in Germany. And so he was confidentially asking Albert Einstein, would you like to be called in Italy as a professor? Einstein was deeply touched, but he declined, saying, I was very moved by your letter. I must openly confess that I would prefer the company of you and of Levi-Civita to that of my colleagues here, but I'm very much bound to my present environment by family, friendship, and business relations. At my age, it is not easy to change environment. But in the future, I feel forced to live if in the future I feel forced to leave this nest of mine due to the worsening of the situation, I will turn to you immediately with joy and trust. Okay, and that's the end of the story. It seems that 10 years later, according to Enriquez's daughter, Enriquez wrote again to Einstein saying, or tried to get in touch with Einstein to see whether he could be still interested, but this time it was Mussolini who opposed it because the political situation has changed in Italy as well. In 1925, the regime had turned into a real dictatorship, and in 1933, by mid-October, Einstein moved to the United States, never to return to Europe. However, he never forgot Italy, as he wrote to Benedetto Croce, our great philosopher, in 1944, wishing that his beautiful homeland, which he loved so much as a young boy, would soon be freed from the evil oppressors from without and within. Okay, now last slide, recalling what Carl Grandin has just said about the Nobel. We have asked, the Italian Physical Society has asked Carl Grandin to write in 2021, so 100 years after the Nobel Prize of Einstein, to write an article on this event. And the title was, from Carl, The Difficult Task to Award Einstein a Nobel Prize. Because so the controversy was so hot, so terrible in 1921 that the prize was suspended. It was awarded to Einstein in 1922, so retroactively, with a sort of escamotage because they gave it at the same time to Niels Bohr, so trying to to find a kind of compromise, and moreover, it was not given to Einstein for relativity, but it was given for the photoelectric effect. And as Carl pointed out, this I will skip, Albert Einstein is the only Nobel Prize winner whose citation for the prize also states for what he did not win it. Actually, it says, Professor Albert Einstein, a Nobel Prize winner for the photoelectric effect, irrespective of the value that, upon confirmation, could be attributed to the theories of relativity and gravity. So, was it a kind of final spite by the Swedish academicians, or, as Carl was pointing out in his article, maybe it was a deliberate choice of the academicians to give Einstein the chance to win a second Nobel Prize, which did not happen. So thank you for your attention.
Thank you, Professor Cifarelli. I bet we have time for a couple of quick questions if anyone has.
No, I don't know anything about this personal life. I tried to separate the scientist from the man. I don't know about there are many stories about the private life of Einstein, his relationship with the wives and so on. I don't know them. Maybe you have the answer.
Actually, I can answer your question. He gave indeed the Nobel Prize money to his first wife. He even promised the money from the prize to her before the prize was awarded to him. He probably wanted to get rid of her.
Just a more comment. In Bern, at the Historic Museum, there is a special section dedicated to Einstein. If you go there, you get a lot more of information about the private life of Einstein and his relation. Most of people don't know that Einstein rejected his original German citizenship. He was born as a subject of the Kingdom of Württemberg. During a certain time, he did not have any citizen. He was apolid. And when he was in Milan, he then applied for Swiss citizenship. And the Swiss authority were very suspicious. And they sent an inspector from Zurich down to Milan to make an inquiry about this weird guy who wanted to become Swiss. And all that is on record there in Bern.
When he left Germany to come to Italy, he also gave up his nationality. Quite a rebel. Hmm?
Let's thank again our speaker. Next speaker is Professor Francesco Fidecaro of University of Pisa, and again from INFN.
So good afternoon. First of all, thank you for the invitation. It's a pleasure to be here. This talk will not have really a strict historical content. I will try to show the connection between what technology gave to this discovery of gravitational waves and how a number of things that were not in the realm of physicists were used in order to achieve this discovery. To do this, I have to spend a little bit of time. In fact, something was anticipated by Luisa about the subject and why it has been so difficult to detect gravitational waves. So let's see whether it works. Mm-hmm. Sì, certo. Mm-hmm. Okay. So I'll go through a little bit of gravitation, geometry, and general relativity. I will use Luisa's words, then go through interferometry, detection, and in fact, there have been, you have heard, of course, but I will go through 2 milestone events that went into the award of a milestone, an historical milestone by IEEE to the gravitational wave interferometers. So let's begin. In fact, we start just to be to expand on the equivalence principle. We start from Galileo. Galileo describes in his discourses the free fall of objects. In fact, the free fall from the Pisa Tower is probably folklore, but he has a very detailed experimental description using pendula of different materials that indeed give a very convincing way to show that bodies fall with the same acceleration, and they are showing that he had really good mastering of experimental work. And so what happens is that all bodies undergo the same acceleration, and what they have in common is the local space and time. And so it's local space and time that will determine the motion of the bodies. From the Einstein point of view, then everything started with the Michelson-Morley-Knowles experiment, and we know that from this experiment that we see light traveling at constant speed for every observer, and special relativity, 1905, is now part of the Eternal system of units, only in 1983, and now space and time are connected by the c speed of light, which is now in the system of unit an exact value. So the connection has been established, recognizing the value of special relativity and meaning of special relativity. The meaning of special relativity is also that it is light that is waving the fabric of space-time. You measure through propagation time through direction, you measure the position, and from 2 places you can measure time using light. So light is really going to be using special relativity, then light weaves space-time. This is what Luisa described. We have the drawing here. So this is the observation by Eddington. We don't see the, is there a pointer? No. I will use this one. We see light bent by the sun, and in case of an eclipse, the light will come from a star that is here, that is going to be bent, is behind the sun, but is seen because this is the apparent, what we believe is the position of the star. And so when the eclipse occurs, the stars around the sun expand with respect to their position. And so especially the calculation was correct, and this was clearly the proof for static general relativity. So we have, there is an observation in architecture. Light generates space. Without light, space doesn't exist. This is Mario Botta in some writing, Luce and Gravità. And so we have the permission to say that light generates space and time, and without light, space and time doesn't exist, which means that if light is not able to go somewhere which doesn't mean anything, then that place doesn't exist. So this is really the meaning of the geometrical interpretation of general relativity. Well, all this then in 1916, when general relativity was exposed 1 year before, then there is an approximate solution which shows that there can be gravitational waves. So gravitational waves are simply the fact that if mass is curved space-time, this doesn't happen instantaneously. And so gravitational waves are going to carry the curvature away from the speed of light, at the speed of light, and they will be able to tell about the mass motion. The interesting thing is that the waveform is preserved, and these are the signals that are traveling in space-time. So how do we detect gravitational waves? What we say is that masses tell space-time how to curve. This we have learned. And space-time tell masses how to move. And this was by John Wheeler. Here we see we've placed a number of masses on a circle, then a gravitational wave that passes by deforms the circle in this way. So there is, on one direction, you have expansion, on the other direction, which we have contraction. This is an important point. So we need a strain gauge for space-time. So we need two masses, should be free from local forces. They should just feel space-time around them. And in our case, these are mirrors. They're macroscopic objects, 40 kilograms. And we need a clock to measure the round-trip time of light. What is the difficulty is that the strain is 10 to the minus 21. This means that over kilometers, you have an elongation which is 10 to the minus 18 meter, to be compared with the atomic radius of 10 to the minus 10, to be compared with the visible light wavelength of 10 to the minus 6, to be compared with vibration on the ground of the same order of magnitude, to be compared with expansion of Earth due to tides of 10 to the minus 4. So in addition to the sensitivity that you need, for engineers, you have also to realize that you have an enormous dynamic range that you must deal with. So it's 10 to the 12 over 1 second measurements. How do we do this? We have interferometers. There, from the idea of Michelson, we have something that is where we send light, we split the light into two different directions, and we compare, because it's difficult to make absolute measurements, we compare variation in distances between the masses. You can use light, this is 1064 nanometers, 1 micron. This was invented in Bell Labs in 1964, but the phase you need, the phase precision you need is 10 to the minus 11 radians, 10 to the minus 11. You can improve the sensitivity by introducing resonant cavities. This is something that we use with radio. We use resonant circuits. Here we use resonant cavities to improve, to be more sensitive to the phase. And so what happens is that with destructive interference, you have no signal. You set up things like that in order, so when you have when the length changes, you have some constructive interference at the beam splitter, and you have some signal that ends up at the photodiode that you see at the bottom. This is the only output. It is one single channel. It is a signal, an audio frequency signal, and this is the gravitational wave that you're going to record. There is a technique that is worth mentioning, and so you use Fabry-Perot cavities. These were invented in 1999, and there is a boundary-roll technique which is used which has been presented in 1983. It has been used in microwaves, and it's used in optics. So what do? You modulate the phase at some frequency. You generate sidebands within the same beam. And the same beam goes into the cavity, but the sidebands are reflected. And so you get back these sidebands. These sidebands are going to interfere with the main beam. And so at the photodiode, you are going to see modulated light. You should realize that you are not able, like an antenna, to measure the electric field of light. So you can only measure intensity. And when you want to see interference, you must have two waves that beat together. And so in the end, you decode with a mixer, low pass, and send, for instance, the feedback, the error signal to control the cavity. So this you can do on a complex object. I'll go fast. You have many lengths that you must control. You must realize that instead of the typical optical setup in which you place mirrors on a bench, here you have mirrors that are floating in the air, they're suspended, they should be free, and your only reference is the light ray. And so you have to control, using these techniques, all the lengths that are present here. the resonance of the cavities, the Michelson, and so on. And so you do something similar. You send some light to measure this according to the Pound River Roll techniques here. You send some other light that is able to go through the cavity and measure, for instance, the optical cavities in the arms, and so you can control your interferometer. Things are more complex. You have also angular alignment, but I'll skip about this. The other thing that needed to be done is to keep the mirror quiet. We have, until now, we have seen how to measure. Now we have to see how to keep the mirror quiet from from local influences. And so what we have done, what has been developed, in particular with the Virgo experiment, is to adopt something that is loosely coupled to the ground. This is this inverted pendulum that you see in the middle of the picture that has flex joints. So it's something where the mass at the top is very loosely coupled to the ground. It has the eigenfrequency is 30 millihertz, and so you have some attenuation. On the right, you see the system, the complete system that can be used, again, using pendula. These are second order low-pass sections in engineering terms. And so this is what you do. You have some filters that are more complex than simple mass, and you suspend your mirror like that. Your mirror is suspended with silica fibers, and you need to steer the mirror, not touching it, applying electromagnetic forces. Okay. So the thing needs to be controlled, and here we have what we call super attenuator, which was invented, was Adalberto Giazzotto, who promoted the Virgo experiment. It's an electromechanical system that has many low-pass filters, and to deal with the dynamic range, we have the chance that this dynamic range works in different frequency bands, and so we split the control of the system into a top part that acts at very low frequency and large amplitude, and then lower parts that are more and more precise. And in this way, we are indeed able to deal with the dynamic range, and we are able to have a transfer function that is able to attenuate the seismic noise as we want. So a few pictures just to show what it looks like in our experiment. Here are the super attenuators with people, the top part with people working on it. And here we have the suspension, the lower part. And here we have, on the right, we have a photograph where you see a silica fiber that we pull ourselves with a controlled profile in order to suspend the mirrors. What happens is that we have we have a noise curve where we try to lower the noise as much as possible. This graph shows as a function of frequency. You can see 10 hertz up to 10 kilohertz. So this audio frequency. You can see what is the noise in terms of strain, 10 to the minus 23 and the like. There are several contributions. Seismic contribution just so low that is outside the graph. You can see it on the left. We have some local gravity. We have some Brownian motion of the pendulum. The pendulum is at room temperature, so you have this noise. You have quantum noise. This is important because by now we are what is being done now is to use squeeze the state of light. We are squeezing the vacuum, the electromagnetic vacuum inside the cavities. So we are using really quantum optic techniques over length of kilometers in a continuous way. For years, we are now doing this in order to reduce the contribution of the noise in both parts, either shot noise, photon counting, or radiation pressure at low frequency. Finally, it's a very nasty thing. Mirrors need coatings. These coatings are 6 micron of layers that are deposited on a 40-kilogram mirror. These 6 micron coatings, it contributes to the noise, to the last noise that we are seeing here, and is clearly a limitation. So what is going on today? Out of all these contributions, scientific and engineering contribution that you have seen, we have been able, since some time, to build these interferometers. The LIGO, funded by United States National Science Foundation, they started funding in 1989. You have with us a LIGO scientific community that has been established. There is Virgo, which has been started funding in 1994. And then we have the Japanese experiment, which is underground, Kagra, that has been funded in 2010. So we are distributed all over the world, and there are a few pictures of it. What are we looking at? So the precious events, gold-plated events, these are binary systems of extremely compact objects. So you should imagine that you have objects that have the mass of the sun concentrated into a few kilometer region that are orbiting one around the other, as you can see on the left. And on the graph below, you can see that these solar mass objects reach about half of the speed of light at the end of their life of the system. On the right, what we are saying is that in this signal, the frequency, the phase history, and the amplitude, out of this, we will have to sort out, and only out of this, we have to sort out the parameters of the system. And so to do this, we have, taking our noise picture, we have the typical source content is being drawn in the thick line, and you can see that typically is below the noise curve. We want to have this noise below because the amplitude is proportional to 1 over r. It is a field, it's not an energy, so you have just the same meaning as the radio transmissions. You can transmit because you have a 1 over r dependence, and so you receive signals over long distances because of this dependence. So what we do, this is borrowed clearly from engineering. So we use Wiener filtering. We use an optimal filter. We use a family of templates that try to match, that will match the signal that is being recorded and try to find the best match. And this match is weighted over frequency by the noise of the detector. This is the principle of Wiener filtering. And let me say that this is a spread spectrum communication system. We are spreading the signal of a gravitational wave over the whole spectrum. It's below the noise, our curve noise. Nevertheless, we can get a signal-to-noise ratio above 1, thanks to Wiener filtering. And so this was born in 1942, as written. So, what did we see? You have seen certainly this picture. So what we had is that the same signals appeared 3,000 kilometers apart in the two US interferometers almost at the same time, within a few milliseconds. And we can recognize the last orbits of a binary black hole system, the merged phase of the two bodies. They're going to compenetrate themselves. And finally, there is a black hole, which is bound to become perfectly spherical, that is ringing down and emitting the last whispers of gravitational waves. So everything of this is recognized, and out of this, you can measure masses and so on. And clearly, this, since we are in Nobel Prize area, this went into the awarding the Nobel Prize in 2017 to Thorne, Weiss, and Barish. The other event was something that is happening that happened in 2017. So we have a satellite that is listening to gamma ray burst outside the atmosphere, and we have the interferometers here. And what happened at some time? I hope it works. Okay. So the first chirp, This is the increase in frequency that you saw in the graphs, and it is represented below in this time frequency graph. And 1 second, 0.7 after, you get an event from the satellite. So completely different things that arrive essentially at the same time. So this, it's extremely unlikely to see something like that. And so it's clear that it is coming from the same place, from the same source. And really, it's matter and waves that tells space-time how to curve, and space-time tells matter and waves how to move. So it means that something that started 100 million years ago traveled. You had the time to extinguish dinosaurs, then you enter the galaxy, you have the Bronze Age, you have Pericles, whatever, and at some moment, within 1 second, you get the same signals on Earth. So this is something that tells that these gravitational waves are very well understood now, and that it is really space-time that is going to drive masses and waves. This opens a new astronomy. Just let me tell you how it works. If you have a wavefront that arrive at the first interferometer, which is marked with this red L, and the interferometers are at some distance, and then you have a second, the same wavefront arrives at the second one, then with this construction, you can reconstruct the angle between the propagation direction and the vector between the two interferometers, and this means that your source is going to be on this circle in the sky. So with 2 interferometers, you find a circle in the sky. With 3 interferometers, you can point. And this is what happened with Virgo joining the experiment. So we were able to determine a very small region within the sky, 28 degrees squared, and this is manageable for astronomers that have a very narrow field of view to look into the sky. And what happened is that we had to wait sunset in Chile, and some telescope comparing current images with the catalog finds a new star. So under the indication of this signal, these gravitational wave signals, we were able to point and find the star. This is, I will skip probably all the details. One just sees that this is not really a star. It's something, a hot ball that is going to cool down. First it's blue, then it becomes red, and we have a nice, there is a spectrum curve that has been analyzed and is showing that all the elements, the heavy elements of the periodic table are built, are synthesized in this sort of events. Okay, I will not just go to the end. Let me see if it's not possible. Okay. Okay. So this means that we have a different communication system that is being set up. We have an early warning by gravitational waves. Interferometers are omnidirectional. They are antennas with a broad antenna pattern. It's completely different from the telescope. And they are sensitive above and below the horizon. The Earth doesn't make anything to gravitational waves. So you don't need to point, you just listen. And this motion anticipates electromagnetic emission. So they can be used to tell, as it has been done, to tell where to point to optical telescopes. And we want to do this in real time so that before the final coalescence has happened, when still there is inspirer, we are able to predict where and when it's going, the collapse is going to happen. So there is a prediction capability, again, through signal analysis, that can be done. So we are set up to study the invisible. Let me just mention the science program with general relativity in extreme curvature is clearly something inaccessible on Earth. We have gravitational wave properties, gravitational wave have polarization. Then the sources are interesting. We go back in time very far away. we see the universe evolution, first galaxies, first stars, and also the unknown. So this is what is expecting us. Currently, we are observing, these are some results that we obtained in the last run. On the right, you can see the number of events during the first run, and the number of events on the vertical axis during the second run in green. And the third run, the sensitivity increased, so the volume of space-time that we can listen to has increased, so we have more sources, more probability, and so the rate is about 1 every 5 days. And today we are running, and the rate is even higher. So all these events went then, and we have to thank Professor Tellini for proposing also us for an IEEE milestone awarded in February of this year. And the citation is in 2015, LIGO's antennas located here in Louisiana, so it's Hanford, first detected gravitational waves produced 1.3 billion years ago from 2 merging black holes. And in 2017, Virgo, which is 60 kilometers from here, and 2 antennas located in the US, launched the era of multi-messenger astronomy, so communication through different channels, with the coordinated detection of gravitational waves from a binary neutron star merger. And so these events that I hope that I have been able to explain you then motivated this milestone that we are honored to have been assigned. Thank you.
Thank you, Professor Fidecaro. Are there any questions from the floor? Yes, please.
Okay, I can speak this question. You said that you, with the interferometer, you can, of course, receive signals both from above and below the horizon. Is there any, when light goes through a medium, you have some delay because there is an index of refraction of the matter. Is there any equivalent effect for gravitational waves? So some expectation that the signal may arrive slightly later if it goes through the Earth?
Just repeat the question for people away. So is there possible delay for gravitational waves that cross the Earth rather than come from above the Earth? So the answer there is the delay is negligible because the interaction between gravitational waves and matter is extremely low. But we are looking for lensing effects of gravitational waves. So you have matter of galaxies, you have enough matter that is going to influence the time of propagation. And this is one of the results of general relativity, is that when you have a wave that comes nearby, say, the sun, in fact, is being seen from the outside, it's being slowed down. And this is the way you can explain deviation of light around the sun, because you have a wave front, and 2 parts of the wave front go at different speed. And so if you use this, and so it works for gravitational waves in the same way, but you need galaxies. And we are looking for lensing effects. So dark matter plus galaxies, you have a lot of them. Gravitational waves cross this, and there the effect can be tangible, but not for Earth. Earth is not enough mass and not enough length.
Thank you very much for this fascinating presentation. I have just a minor question. The basic principle is to detect signals in the presence of noise. Can you tell us something about the confidence level, or if you prefer, the detection threshold you use in the experiments?
So, come back to the Wiener filtering. We have some There we have the result of the Wiener filter. And what we do is that you have to realize that this would be for one single waveform. But we are listening for waveforms practically every millisecond. We have to shift in time. So over 1 year, it means 3 times 10 to the 10 different trials that we do. And we are applying 100,000 templates. So in the end, it's 10 to the 15 different trials on the same data. And so even if you consider Gaussian distribution, you must go far away. And our threshold for Gaussian noise, which is not really the case, is 8 sigma. 8 sigma? Yes. But we want the coincidence. There's no way, because we have then we have outliers.
Okay, let's thank again our speaker. By the way, Antonio Savini, who is the next speaker, has got disconnected and is trying to connect again. So we have 5 minutes to stretch our legs in the meantime. And I remind you that there are complimentary books for you if you want. I need to contact the speaker. Can we speak later on? Yeah. Sorry, I need to. Dice che non lo fai.
Ma prima c'era il link. Non è che si è sbagliato col link. Io abito su Lungardi verso Piazza Alberti e poi ci sono mia mamma abitava lì a Mancano, Piazza Alberti. Ci sono venuto qua con mio padre, penso anche c'era il libro sulla condizione degli strumenti poi avevo trovato anche alcuni video con questi loro.
Se vuole tornare io ci sono di solito la mattina, venerdì, quindi io mi chiama.
E lì poi ci sono i laboratori, cioè ci sono gli strumenti esposti. Una volta ci fu volentieri anche per il laboratorio. Sì, tutto a posto, ora c'è un problema.
Pronto? Pronto?
Sì, ci sentiamo.
Ecco, io mi sono ricollegato.
Ok, perfetto, ok.
Per me va bene adesso. Scusate, ma c'è stato un blackout proprio elettrico, il computer si era spento.
Perfetto. Sorry, Antonio Savini is back online, so please go back to your seats.
Se può presentare lo schermo così vediamo se funziona.
Lo presentate voi lo schermo?
Lo dovrebbe presentare lei lo schermo, oppure ci manda per le slide per email.
Lei lo mandate?
Allora controlliamo un attimo.
Antonio, scusa, quando ce le hai mandate che ora non Antonio, l'ho trovata. No, no, la presento da qui, si fa bene. No, presento lo schermo. Come faccio che andare a tutto schermo?
Che cos'è?
È la presentazione.
Provo a fare...
Aspetta, prima...
Scusa, dove?
No,
Perché con la nuova CTRL... Visualizza...
Presentazione.
Okay.
Okay, so our next speaker is Antonio Savini from Research Center for the History of Electrical Technology of the University of Pavia and the Museum and of course the History Committee Chair, as it's been reminded before. So please, Antonio, and tell me when you want to change slide.
Yes, thank you so much. Can you hear me?
Yes.
Okay, thank you so much. I'm sorry, I'm connecting at a distance, and sometimes not the technology which is essential to solve problems sometimes as failures. Like a few minutes ago, I have a disconnection, and so I had to resend all my slides of presentation. Good afternoon to everybody. I've been invited to speak about museums of science and technology because of my experience in the foundation of a museum of electrical technology, just in Pavia, my own town. Within this large subject, I have concentrated my attention to museums of information and communication technology, paying attention also to the impact of this technology to museums in general. So the title of what it will be in my short survey is what you see on the screen, Museums of Information Technology and Information Technology in Museums. Next slide, please. Histelcon this year takes place in the heart of Florence, which is a magnificent city with a glorious past, particularly in the age of humanism, a cultural movement which got inspiration from the last to create the new. And the result of the new create is unreachable. Francesco Petrarca, one of the fathers of humanism, wrote a few words to express his way of life. In Latin, simulant retroque perspicere. In English, looking forwards and backwards at the same time, which is a motto useful for every time and all aspects of life. Next. Museums, in a broad sense, are places where the past is preserved and inspires the future. Since you are in Florence, I would like to mention in this connection for museums of art, the Uffizi Museum, for science museums, the Galileo museums. You will see the pictures on the right of the screen. For science and technology museums, the Fondazione Scienza e Tecnica. I hope you will be the opportunity of visiting these museums and many others. Next, please. It is a common opinion that since over 50 years we live in the so-called information or digital age. 50 years ago, just to have a difference between the past and the present, 50 years ago we had phones on desks or walls to transfer just voice by wires in analog way. To perform calculations on a desk, we had calculators. That's all. Nowadays, each of us has a smartphone on his or her pocket, and the phone transfers data, digital data, to and from everywhere, wireless, and is much powerful than an early big computer. To the right, on top you see the microprocessor installed in one of the early smartphones. It was even at that time as powerful as many early big computers. The information society intensively uses information and communications technologies in all areas. I will shorten sometime as the term information and communication society into information society, but I mean the same things for the two. Next slide, please. Information society deserves or urges to become the subject of specialized collections and museums or specialized sections of general purpose museums. As an example, I've taken the case of the Science Museum London, founded in the middle of the 19th century. You will see some pictures to the right. It is a well-known general purpose museum which early started to exhibit exactly the information age. On the right, you can see also the computer used in 1990 by Tim Berners-Lee to design the web, a fundamental step in the evolution of ICT. Next, please. Science Museum is a museum of science. Now concerning general purpose museum or centers, as an example, I take the Centre Pompidou, Paris, known as Beaubourg also. It is a modern center of art and technology dating back to the 1970s. It intensively uses technology and particularly ICT technology for exhibitions and shows. What is particular is that it exhibits this technology instead of hiding it. This is peculiar of this museum or this center in this case. Please. Next. And here we come to the two faces of the binomial or the two faces of the coin, which are the two parts of my survey. On one part, examples or museums of information technology. On the other one, examples of impact of information technology on museums. Next. Here a survey of museums of information technology starts according to the origin. Sometimes cradles of future museums are the sites where exceptional achievements of such a technology took place. In Europe, we know that Alan Turing was the head of the team working on decrypting the German naval enigma at Bletchley Park, United Kingdom. He designed the famous bomb machines which paved the way for the first computer to be built, the Colossus Mark I, kept secret and then dismantled. A functioning rebuild of Colossus was completely in 2008 and is on display at the National Museum of Computing, UK. Next. In America, the so-called Silicon Valley has the greatest concentration of innovative centers of ICT technology in the world. Here in Mountain View, the Computer History Museum is located. It claims to have the largest and most significant collection of computing artifacts, including a Cray 1 supercomputer. It started in the shape of a collection which moved sometimes and was increased by donations. By the way, in this museum, we can see the biggest collection of concentration of IEEE milestone in the field of this technology. Next. Turning to Italy, in Pisa, the first scientific computer was promoted by Enrico Fermi, Nobel Prize winner in 1961. The slide shows the museums of computer machinery in Pisa, which host this first Italian computer. Next. Returning to America. In America, there is in Washington, D.C., there is the large National Museum of American History. In the 60s, the frontiers of technology and science were in the space. The spatial research was supplied by the innovation, information and communication technology. Well, in 1990, the museum opened a huge exhibition with the title Information Age, People, Information and Technology. You will see some pictures to the right. Next. Back to Europe, a traditional new museum of electrical technology was opened in Pavia, my hometown, at the university where Alessandro Volta used to be a teacher. The museum includes an important collection of early electrical communications, telegraphs and telephones. You see a picture of the one of the halls of the museum. By the way, in 2012, the Pavia Museum hosted the third Histelcon after Paris and Madrid. Next. In the world, in the past decades, many museums or science centers, either with section of information and communication technology or fully concerned with information and communication technology, were open. The picture shows a spectacular science center in Ottawa, Canada. Next. ICT museums may have different origins, individuals, institutions, users, producer. With reference to producers, sometimes companies producing such a technology created their own museum to preserve the company's historical heritage. This, for instance, is the case of IBM, at Earlsley Park, United Kingdom, where there is one of their R&D laboratory. You can see the building to the right on the bottom. And in America, for instance, I've taken as an example the Intel Museum in Santa Clara, California. Next. Continuing along the line of showing different origins of museums and collections, often teachers of such a technology in universities or schools used to collect vintage technology and create stores or archives for teaching purposes. To represent this case, I have selected the collection set up by Professor Giacomo Bucci at the University of Florence. The collection, by the way, is described in a note in the series of history notes promoted by the History Activity Committee of the IEEE Italy section, as you can see from to the right of the slide. Next. We reach the bottom of the line concerning the origin of collections. At the bottom, we find a multitude of simply amateurs of vintage technology, calculators, telephone sets, radios, audio and video players, and so on. They normally collect and pile up, often in their own houses, every kind of disused devices. Sometimes their collections grow, other times they stop and merge with other collections. Next. Looking around in general, we observe that more and more, owing to the diffusion of information and communication technology and increasing interest of the young generations for it, Science Museum and Science Center offer space to inform, educate, and entertain the general public about the technology. I can quote many examples. I've just taken the case of the Deutsches Museum München, where there is a section devoted to informatics, showing in particular the German contribution to it. Next. Just a remark about the evolution of Science and Technology Museum. The trend is to move from building a huge museum to specialized museums, from static to dynamic interactive museums, from physical museums to virtual museums. There is no room to describe in particular the IEEE initiatives of creating a museum. Very shortly, in the first years of this century, the idea of a virtual museum was developed. Then it was replaced by the project of the IEEE Global History Network. More recently, the project of the IEEE Global Museum is in progress. It consists essentially in a network of places where the memory of IEEE and the achievement of IEEE recognized by IEEE in this technology are shown. The picture shows to the right a showcase in New York City at the headquarters of IEEE. Next. Here we start the second part of my presentation. The information technology has changed our lives in the past 50 years. I've already spoken about that. It has changed our life. It has changed also museums. How the technology has shown museums. This is our what I intention to describe now. The picture shows just recent tools used also in museum to improve the functioning of the museum. Next. About the production of museum catalogs, I remember, maybe other people remember, when paper catalogs were replaced by analog technology of microfilms, soon replaced in turn by digital technology. As concerns of another essential function of a museum, that of preservation, each physical museum has a repository of objects that it is not possible to exhibit. Normally, the repository is not visible and there's no catalog. As an example, on the contrary, of good practice for store and cataloging, here is, I would like to present the case of the Musée des Arts et Métiers Paris, which in the 1990s promoted a huge renovation project and made the store collection visible. Next. Another big museum in Europe is the Deutsches Museum, founded at the beginning of the 20th century. It is famous for its dioramas. One of these is represented in the slide. They are static representations of scene of life. Very good, very interesting, but they represent the past. Modern technologies now enable to have living representations, also interactive. I remember when the first trials have been put in practice to introduce audio cassettes and headphones when offered to visitors to help their tour in museums. Again, the digital technology now replaces this tool by computerized system. Next. During the 1980s and 1990s, the advent of personal computers and the internet revolutionized the museum world. Touch screens and hands-on experiments made the visits more attractive. Next. Probably I have to speed up, but a few slides more. Information about a collection nowadays, or a piece of a collection, can be taken not from static panels, but using smartphones and getting information simply approaching them to QR codes. Next. Advanced technologies made it possible to create virtual tours of the collections, so attracting visitors. Google Street, a function of Google Map and Google Earth, was launched in 2017 to offer 3D images of buildings of places in the world. As an example of its application, about that time, the Metropolitan Museum, New York, started to propose self-guided tours of the collection in a spectacular, immersive, and interactive way. As you can see, unfortunately, it is static on the top right on the slide. Next. Using advanced software technology, virtual presentation of museums were and are created. Nowadays, all museums, small or large, have a virtual presentation which is accessible easily on the web. The slide shows the opening page of the Uffizi virtual presentation. but as a final result, also totally new virtual museums can be realized. Next. By making use of the emerging interaction techniques of virtual reality, computer-generated environments can be created, collecting data in real time by cameras, small cameras, and observing creating environments by small glasses. Augmented reality adds real elements to the digital environment. Next. Nowadays, the frontier of the research about the use of information technology in museums is represented by the so-called metaverse. There are large investments in the metaverse in all aspects of the life. Experiments of metaverse in museums are in progress. Next, we are going to conclude. Some final remarks about my vision, at least, of the future of museums and information technology museums. Physical collection will continue to be created. Traditional museums will continue to be created, pursuing their missions, that's to hold the collection in perpetuity. At the same time, more and more virtual exhibitions and museums will be planned. New museums will have stores of physical objects and a few pieces exhibiting in fascinating way. Networks of museums will be proposed and realized for both real and virtual museums. In this final connection, I wish to mention Google Arts and Culture. Established in 2011, it is a network of leading museums and archives in the world offering virtual visit. It includes, for instance, Uffizi Gallery, Galileo Museum, and other treasures in Firenze, the town which hosts the Histelcon this year. Next, I think, is the end of this is the end of my survey. I would like to thank you very much for your attention. Thank you.
Thank you, Antonio. I wonder if there are questions for you. Okay. So thank you again, Antonio, and we should move on with Anna Giatti from the Fondazione Scienza e Tecnica in Firenze. Dovrebbe prenderla lui la condivisione. Intanto usciamo. Devi riprendere la condivisione te.
È dentro.
And thank you for inviting me for speaking about Paolo Brendi and the world of historical scientific instruments. In September 1985, I enrolled at university, and in order to look for a small job, I asked the Museo Galileo in Florence. I had done a school and work experience there the previous year. I was lucky. In 1980s, interest in historical and scientific heritage was flourishing in Italy, and the Florentine Museum was at the center of this process. Important exhibitions were inaugurated in those years that bore witness to a new way of seeing, studying, and communicating scientific instrument collection. That climate also favored the rediscovery of forgotten or not well-considered collections. Among these was a beautiful collection of 19th century scientific instruments, that of the Physics Cabinet of the Technical Institute of Florence, which today constitutes the main part of the museum of the Fondazione Scienze Tecnica, and where Paolo Brenni spent a large part of his professional life. In these photos, we see what the collection looks like today. And here is Paolo, in the recent year, proudly standing among the instruments of that collection, in front of one of his favorites. In 1985, Paolo was already involved in the world of the scientific instruments, thanks to a collaboration with the University of Pavia, where he met Professor Salvini, and through some early international contacts. He had just started to reorganize, study, and restore the entire Florentine collection, and I had the opportunity to help him. It was like going to the playground and not to work. Every day, I could choose a new instrument, and usually Paolo could already identify it, how it worked, what it was for, if any part was missing. Even though he was still very young, I felt he already knew everything. I was very impressed by this experience. But it was only a few years later that I realized what a unique relationship this had given me to scientific instruments. I had received a very peculiar imprinting, and this was thanks to the impressive broad knowledge of Paolo. In 1987, the region of Tuscany organized a course devoted to the identification, cataloging, and restoration of historical scientific instruments. It was, of course, just an introduction to a very complex field of research and to a so peculiar practical work as the restoration is. The course was an innovative and pioneering initiative, a milestone in the process of teaching specialists in the field. Of course, Paolo was a key person in the teaching staff. The very few photographs taken during the course, no digital photography at the time, testify that the hours of practical work were greatly appreciated and helped to strengthen relations between the participants, as you can imagine. In the years that followed, Paolo continued to conduct passionate research in the field of scientific instruments, and this also benefited the pioneer restoration work that he always carried out along with his prolific research and writing. One important restoration was of a very complex instrument, the meteorograph of Father Angelo Secchi. The restoration was conducted on behalf of the Museo Galileo, partly at the Opificio delle Pietre Dure and mainly at the Fondazione Scienze e Tecnica Restoration Workshop. The Opificio delle Pietre Dure, here in Florence, is one of the international temples of art restoration, and thanks to the sensitivity of one of its directors, Giorgio Bonsanti, this experience started a dialogue that culminated in a congress in December 1998, the restoration of scientific instruments, and proceedings were published. During the congress, Paolo presented a paper entitled Better the New, Scientific Instrument Restoration in Italy. and thus set out a number of fundamental talks that summarized his view of the matter. A deep knowledge of the objects is obviously the most important thing. Easy for him. Paolo had specialized in many fields related with scientific instruments, from the history of science and technology to the history of the precision industry, to the scientific aspects of the disciplines, to the tacit knowledge in the experimental science, and maybe more. Normally, a team of people would be needed. Then, during the recovery of a historical collection, restoration is a crucial action, more challenging than cataloging, displaying, etc. This is because it might not be reversible. Scientific instruments encompass a huge group of objects, and when it comes to their restoration, certain features make a big difference. First and foremost is the era of construction of the objects. Dealing with the function of the instrument, Paolo invoked a research of balancing. Paolo was attracted by the operational side of the science, and he was really confident in handling objects, but he had the sensitivity of an historian. To restore is not to repair. And first, an instrument is a historical source. You have to take it in account, but you also have to consider that the use of an object is the core of its meaning. So you have to find a compromise between all of these aspects. For the same reasons that we shouldn't restore a historical artifacts as better than new, we shouldn't restore it as a new instrument either. It has its history, and its historical and cultural value has to be preserved. If in doubt, don't do. An improper action could be more dangerous than doing nothing. If in the restoration of art, concepts like these are well established, for the scientific and technological heritage, there wasn't a tradition, nor any specific educational trainings, at least in Italy. So these statements were foundational. He preferred to reassemble than to rebuild. Initially, in the physics cabinet in Florence, some of the material were dismantled and scattered in attics and cellars. It often happened that he would call me in the morning during his trips abroad to tell me, "Last night I had an insight. That piece we saw in the cellar is part of his time of instrument. Please go and check." He held in his mind a precise map of all of the instruments and of all of the scattered parts. Likely, his brain was able to immediately grasp the soul and the engineering of every device. Thanks to this skill, and obviously thanks to his wide knowledge, he was able to identify any instruments. Paolo passed away too early and suddenly, leaving his family, his friends, his colleagues, and the entire international scientific instrument community stunned. A great consolation are the many seeds that Paolo has sown, with his publication, his lectures, his generosity. He produced many articles and books, a production that testifies to our difficulty in reporting a complete reconstruction of his entire work. I highly recommend, for those interested, to read the obituary written by a historian of science, Marco Beretta, which is online and open access, where you can find a lot of useful information and, most of all, the complete bibliography. The Scientific Instrument Society, of which he was acting president at the time of his passing, dedicated most part of a bulletin with writings by colleagues in Paolo's memory. Countless condolence messages circulated on the mailing list, and as many were addressed to the family. The past year, a plenary session of the annual symposium of the Scientific Instrument Commission was devoted to him, and countless initiatives have been organized in many countries to honor his memory. The man here in the picture with Paolo was Gerard Turner. Gerard Turner has been one of the main pillars in the study of historical instruments. He highlighted the importance of a deep and thorough observation of the objects, what we call a forensic examination. And Paolo considered Professor Turner his mentor. Paolo was proudly Swiss, but he always considered Italy his second home. And last December, the Italian Society for the History of Physics and Astronomy organized with Museo Galileo and under the patronage of the Italian Society of the History of Science, a conference to celebrate him. Museo Galileo also has established a scholarship, and other Italian and foreign institutions decided to continue for subsequent editions. Paolo Brenni was a very pleasant, nice, and generous person. He used to share his vast knowledge with researchers, curators, experts, and students, with generosity and enthusiasm. He was asked for opinion from all over the world. In his career, he got his hands on many collections, many instruments. Here in Florence, we should be grateful that he has spent a lot of time and effort in our collection and institution. Very often, he was asked to speak in important official occasions, such as the Pacinotti's milestone ceremony, organized by IEEE in 2018, where he gave a talk entitled From Barlow Wheel to Pacinotti Machine. In addition to the esteem of many people who were able to appreciate his work and expertise, his career earned him many prizes and awards. He received an appointment to the Saturn Chair of History of Science at the Ghent University in Belgium for the academic year 2000-2001. The Paul Bunge Prize for the Jenemann Stiftung for Studies on Scientific Instrument and Material Culture in 2002. The Scientific Instrument Society Medal in 2005. And the Marc-August Pictet Medal from the Geneva Committee in 2013. He was also president of the Scientific Instrument Commission for 10 years and president of the Scientific Instrument Society from 2005 to his death. Marco Beretta, in his obituary, wrote, Paolo's intellectual qualities were truly inseparable from his physical presence. This exceptionally rare harmony between intellect and manual dexterity was the key to his unique ability to tackle the history of scientific instrument. Indeed, Paolo exercised his superb skills above all with his hands, assembling, taking apart, repairing, and restoring the most complex scientific instrument, whose origin and function he was nearly always able to figure out. I completely agree, and many facts confirm this. In 2017, Professor Jed Buchwald and Dr. Chen Pang Yang asked Paolo, as part of their research, to collaborate to replicate one of the experiments that led Heinrich Hertz to the discovery of electromagnetic waves. After the construction of some parts, and thanks to the presence of some historical devices in the Fondazione Scienze e Tecnica, we were able to get the experiments up and running. The ability to set up experience and make historical instrument work can still be appreciated today through a series of video clips freely available on YouTube. Sorry. The videos, filmed for years until 2015, show many historical instruments, their operation, and experiments philologically reconstructed. There is also a video available with the singing arc experience. I saw in the program that you will have a presentation on the singing arc during the conference. Videos has always been very successful. Some have reached a number of views we never imagined. The bell is ringing. This, with the Earth's experiment, counts more than 70,000 views. The experiment is repeated with different settings. And so on. You can watch the video in the YouTube channel if you like. His familiarity with science, technology, instrument, experiments, process, and chemicals stemmed from his not necessary scholastic training. He was born in Mendrisio, Switzerland, in 1954. After graduating from high school in Lugano, he studied experimental physics, of which he had been fascinated since childhood, obtaining his degree in the Zurich University. But he told me that as a child he had used and abused science kits for boys, handling substances that horrify us today. He spent his childhood in a family where scientific and technical knowledge had a large place. One grandfather was a doctor and a stereoscopic photography enthusiast. The other, the director of a tanning factory in the Mendrisio area, where his family had always lived and where Paolo had returned in recent years. He liked to remember about the old-fashioned tanning company and his incursions there as a child. I believe that these aspects were also important for Paolo's education, along with his skills and studies, of course. The result was really something special, and we lost a lot when he passed away. He was passionate about the 19th century, especially the second half, with the Second Industrial Revolution and all the invention and innovation it brought. He knew very well that century, and not only from a scientific and technological point of view. In fact, he had also delved into other related topics, such as the figurative arts and the social aspects of scientific progress, thus building a very interdisciplinary knowledge. We can think of him as a man with his feet in the 19th century and his head in the third millennium. So, thank you, Paolo, and thank you to you for your attention.
Thank you, Dr. Giatti. Are there any question for our speaker?
I have a comment.
Yes, please.
Yes. Just to say that I greatly appreciated this presentation of Paolo a great man who worked at the frontier of history of science and history of technology. It gave me emotion, in particular, a picture which was shown at the beginning, showing Paolo standing and a large induction coils behind. That was the subject of one of his more recent work. And at that time, he asked help to me, and I helped him in particular in looking for literature in the IEEE library. Finally, I would like to mention also concerning Histelcon, because we are in the Histelcon context, that he contributed to the third Histelcon which took place in Pavia, and I'm very proud of that. Thank you.
Okay, thank you.
Thank you again. Now it's time for our last speaker, Peter Kurz, patent attorney in the European Union, Switzerland, and Germany.
Oh, great. How do I advance? Okay. So, good evening, everybody. Thanks very much for staying that long in the day. I will do my best to keep you awake for the rest of the evening, which is my associated 30 minutes, yeah, not the whole evening. So let me start with a question. What am I actually doing here? I am not a scientist. I am an attorney. I am not going to talk about history of electrotechnology. I'm rather going to talk about the 15th and the 16th century. And there was no electrotechnology at that time. And what's even worse, as of today, I'm not even a member of IEEE yet. Sorry for that, yeah? So what can I say in my defense? Well, my main defense is that I'm acquainted with Hugo Wiss, who twisted my arm to get me talk at this conference. And we got in touch because I have written a novel about history of science, which is the subject of a talk tomorrow. But Hugo read it and was very, I think you quite liked it. Yeah? It's here, yeah, and I'm going to pass it around. Yeah. In addition, I'm not a normal attorney, a regular attorney. I'm a patent attorney. And as a patent attorney, I also have a technical degree. So actually, I am an electronics engineer. Yeah? I have defected and joined the dark side and became an attorney, but still I have a technical background. And the last thing is, I have a strong interest in the history of patents. And I have also written a big book about that. And I'm going to give both books to Hugo for passing them around. Would you be so kind, Hugo? By the way, this is not a commercial. This book about the history of patents is a great book, but it has two distinct disadvantages. Number one is it's available in German only. And number two, it's out of print anyway. So you can get it only in a library, but cannot buy it. So what's my goal for the talk of today? What I really want to achieve is that when you leave this conference and go home, you should remember that you have been in the birthplace of patent law. This was the origins, the real origins of patents was in Florence and Venice, and this is the rest of my talk of today, what I will tell you about. And obviously, as the title says already, we have two people here, Filippo Brunelleschi and Galilei. and they play a significant role into that. I'm not going to talk too much about these two gentlemen. That would be the subject of another lecture, I guess, yeah. But you all know Galilei, and you all know that Brunelleschi has been the architect of the dome in Florence, and of the cathedral Santa Maria del Fiore, and both were ancient and early patent holders. But before we go to that, let's take a step back. For almost 300 years, the scientific community, in particular historians, were of the opinion that the first patent law in the world was in England, namely in 1624, the English Statute of Monopolies. And what I'm showing you here is only section 6 of the Statute of Monopolies. If you are looking more closely, the Statute of Monopolies was not really a patent law. It was actually a law against monopolies. At the time, monopolies were used to a large extent in England to generate income for the crown. So you had monopolies for producing and selling salt, for example, monopolies for printing school books, monopolies for collecting fines, all sorts of monopolies which had nothing to do with inventions. So the purpose of the Statute of Monopolies was to get rid of all of these monopolies with one exception, and this exception was patents of invention. And what was also important at the time, patents of importation. We don't have that today anymore, but it was very, in a medieval and society and after, that was a tool of attracting foreign artisans to your country. So in Venice, for example, there was a certain Giovanni de Spura who brought the art of printing, according to Gutenberg, to Venice, and Venice became a very viable competitor to Germany at the time. And he got a patent of importation for that. He was not the inventor. He was in Germany, had looked what Gutenberg was doing and brought it to Venice, yeah, very successfully. And the states who were affected by these patents of importation had also their countermeasures. One particular example here is from Florence, where the silk Guild had a rule that said artisans in the silk in the silk technology leaving the city shall be punished by death. I'm not sure whether this rule was ever put into practice, whether people were ever executed, but it was written there. So it was a two-part game with these patents of importation. The other thing is obviously real patents of innovation, and to that I'll come into a minute. If we look at this extract, that's the part of the Statute of Monopolies that really deals with patents. And it says here, provided also and be it declared and enacted that any declaration before mentioned shall not extend to any letters, patents, and grant of privileges for the term of 14 years or under. So the patents were actually for 14 years. Why was it 14 years? The reason was very simple. The apprenticeship at that time lasted 7 years, and 14 years gave the patentee the opportunity to educate 2 generations of apprentices. So this was clearly aimed at the importation of technology, not to the invention of technology. Enough about the English patent system. I just want to mention that it was so rotten that it had you had to pay 10 or 11 fees to get your patent in England without the patent ever being materially examined. And there was a patent reform committee in the 1850s, and Charles Dickens was a member of that committee, and he wrote a novel that is called A Poor Man's Tale of a Patent. And if you if you are bored by my talk here, take your mobile phone and look for this novel. It's really fun to read. It's only 10 pages also, and you will enjoy it. So, anyway, enough of the English patent system. Let's go back to the Renaissance cities in Italy. In 1830 to 1840, there was a German scholar by the name of Johannes Guy, and he was Italicized, and the name was Italicized later into Giovanni Guy, yeah? So that was his Italian name, and he was actually working on the correspondence between Italian artists. He was working in Italian archives and was publishing what he found there. And 3 volumes have been published. And when I was in in Florence the last time, I went to a second-hand bookstore and asked the librarian, can you take care that I get this book? And they said, oh, it's very rare. It costs hundreds of euros. Do you really want to do that? And I said, maybe not. But what happened meanwhile is that an English publisher has reprinted the whole thing, and that's the first volume here. And it contains a patent that has been granted to Filippo Brunelleschi. I have put a marker in there, and Hugo, if you would be so kind again and pass it around. So this is the book that you see here in a reprint. Now, this one privilege for Brunelleschi was granted in 1421, and it is commonly considered the first patent of invention in the world, at least for what we know today. There have been earlier patents, but these have been patents of importation. And do you know now what patents of importation are, right? No problem, yeah. For example, in Bordeaux, in France, there have even been in the 13th century grants patents of importation, but no patents of invention. The grant to Brunelleschi was definitely the first patent of invention in the world. What you see here, this part is from the book, from Guy, that I'm passing around. And here is a reprint from the Biblioteca Nazionale in Florence, and this is part of the text translated into English, and I don't want to leave here without at least citing part of it, yeah, because it says here, no person in being, wherever born and of whatever status, dignity, quality, and grade, shall dare or presume within 3 years next following from the day when the present provision has been approved in the Council of Florence, no signoria, to commit any of the following acts on the river, blah, 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 blah. What they are doing here is, oh no, I need to continue here, to have, hold, or use in any manner, be newly invented or made in new form, a machine or ship or other instrument designed to import or ship or transport on water any merchandise. So what they are doing here is they are essentially freezing the art. They are saying no one shall conceive a new device other than those that have already been in existence. And they are doing that in the favor of Brunelleschi. That is very difficult. If you did that today, yeah, that would stop the advance of science and technology for 20 years. Now, the good thing about that is it was only for 3 years. And actually, when Brunelleschi was about to put his invention into operation, the patent had already expired. So the 3 years were not really harmful at the time, but it would obviously not something that would be viable today. Now, what did Brunelleschi actually invent? It was a ship. One of Brunelleschi's problems was he had to get the marble from the quarries in Carrara, up here, to Florence, here. And the first part of the journey is easy because it's on the high seas. You load the marble here on a ship on the high seas and move it down to Pisa, to Marina di Pisa. That's the easy one. But the Arno, the second part, the Arno is very flat, in particular in summertime. You need a very special ship with, that doesn't go very, very deep, yeah? And obviously, his invention was related to a ship of that kind. We are not really sure how the ship looked like. The only thing that has survived is this drawing from Marino Taccola. He was a contemporary of Brunelleschi and an engineer, and the two had talked about Brunelleschi's ship. But Brunelleschi had never made a drawing of his ship, yeah? So this was the engineer who did it, and this is how he understood that it could have worked. I have not been able, actually, to find a full description of this picture, other than it has been published. But my reading of it is the ship in the background, the ship over here, that's a sailing ship, as you may see. This was the ship that took the marble from Carrara to Pisa on the high seas. That was the easy part of it. And the second part of it, that was probably Brunelleschi's invention, a ship that could move on the Arno, but could also move over land. That's how Taccola thought it would work. He has never seen it himself. He just put up the drawing. So if you look on the web today and look how Brunelleschi's ship might have looked like, you find all sorts of interesting but probably incorrect drawings. This one is obviously according to Taccola's drawing, no question. But this one is a bit strange. So it has gears. This is wind-driven, and it drives the pedals here. Whether this would work on the Arno, I'm not really that sure. Anyway, let's go ahead. So, Brunelleschi's grant, as I said, and you will never forget that, I hope so, yeah, he was the first patentee in the world. At least in terms of a patent of inventions. Still, this patent did not lead to a constant practice in Florence of granting patents. There have been a couple of grants, but not very many. But there have been other Italian states at the time, outside of the reign of the Medici. And could there have been cities that did better? For example, has there been a republic with a need for technical innovation? For example, to dredge the canals or operate its mills or ships? Guess where? Venice, obviously. Yeah? So we come to the first patent law in the world. That's the Parte Veneziana, the patent law of Venice. I'm not really good at reading this old mixture of Italian with some Latin elements in it. What I can tell you here is that 116 people were in favor of it, 3 abstentia, and 3 voted against it. So it was easily accepted. It was 1 page, and that's the reason why I'm putting it up here. You'll find it also in the written publication on it. Let me see. Yeah. So this is an English translation of the whole Parte Veneziana. It is, as I said, 1 page, and it contains all elements that patent law needs to have, even in today's world. And I'm so impressed by that. If you look at modern patent law, a good example is the European Patent Convention. The latest, meanwhile, it's no longer printed anymore, it's only electronically distributed, but the last edition in print that I have in my library is 800 pages. So, and the people in Venice did it on 1 page and had everything of importance in there. I'm not going to read the first one, this is the preamble. why they want patents in Venice and why they want to support technology. If you look at the publications of the European Commission, normally the preamble takes 8 to 10 pages in one language, yeah? Not in 23 or 26, whatever the count is at the moment. And the second part of it impresses me as a patent attorney even more, because it says here, therefore, decision will be passed that by authority of this council, each person who will make in the city any new and ingenious contrivance. New and ingenious. This is something that we didn't have in many patents law in the world. They only required novelty. New, it had to be new. Only about 50 years ago was the other requirement of an inventive step introduced in the patent laws, for example, in Europe, in Italy, in Germany, and so on. So that people in Venice had that already in their act, I found that very, very impressive. It also has to be reduced to perfection. And those of you who have ever been exposed to a US patent may know that reduction to practice is still today one of the requirements before the US Patent Office. Last point here is the duration of the patent was 10 years down here. And now let's come to the last. How am I doing time-wise? I still have a 5 to 10 minutes max? Okay. And the last part of it deals with the question, what do you do in case of someone infringes the patent? And what is interesting here is we have a fine of 100 ducats and the contrivance be immediately destroyed. That is also something that we are seeing being reintroduced into modern patent laws, the destruction of the infringing device. The Venetians had that already. So all in all, a very impressive law that could be a model for the laws of today. And that is the last part of my presentation. We even have an interesting patent, although more than 100 years later. That's a grant of 1594 to Galileo Galilei. This is again reproduction from a local library. The funny thing is, this is a Venetian patent. Why did Galilei get a Venetian patent? Yeah, right. He was born in Pisa, as you know, yeah, but taught as a professor in Padua for 18 years. And Padua belonged to Venice, so he applied for a Venetian patent. The details of the patent grant are in the Archivio di Stato in Venice, but the patent itself is in the local archives in Florence. And why is that? Probably because Galilei, when he returned to Florence, took the patent with him. So that's my interpretation. I don't have proof for that, but it's the natural thing. So what did he actually invent? He invented a machine for raising water, or called a horse chin. We have later a picture of that, but before I do that, I can show you a part of his grant. The interesting thing about this grant is that it's partially in Latin and partially in Italian. The outer part, the text that is identical in all patents has been written in Latin. That's the one here. And the parts of it, these parts are in Italian, right? And let me see, I can just want to show you a part of this Italian section of Galilei's patent, number one. It has been, now I don't speak Italian, yeah? What I have here in front of me is an English translation, and I'm quoting from that, yeah? But it says it's good for 20 years, no longer 10 years as the Venetian law says. And it's for driving with the motive power of a single horse, water, to discharge water. And remember the single horse for my next and last slide. And there's also a fine, but no longer 100 ducats as in the Venetian law, but 300 ducats. And it says 1/3 of it, namely 100 ducats, are going to the informer, the people who informed the authorities about the infringement of the patent. And 1/3 goes to the magistrate that renders the judgment, in other words, the judges. Oh, I would like to be a judge under that law. That probably didn't come. And the 1/3 to our arsenal. That was obviously very Venetian, yeah? So very nice what happened to that. Now, how did Galileo's invention look like? Again, we are, like in the case of Brunelleschi, we are not really sure, but in the Museo di Storia della Scienza, which is now the Museo Galilei, they have a model. And they think this is how it looked like. So the horses are going in circles here and driving this excenter with the 4 pumps here, and the whole thing is pumping up water. And you remember that the Grants had 1 horse, but they have 2 here, so it again shows they are not really sure whether it has looked like that, but it's an assumption. Was it, and that's the last point of it, a commercial success? No, it wasn't actually. It was used in the garden of the Contarini, that was a Venetian noble family, but that was the only use that we have heard. Was Brunelleschi's ship a success? Sorry, I have to say no. It drowned during its maiden voyage, namely near Empoli. Yeah? It lost the marble, and we know from Brunelleschi's tax records that he lost about 1/3 of his fortune through the manufacture and the loss of the naval, because the Opera della Dome, yeah? He wanted the money back from him, yeah, and gave the task to someone else. So both patentees gave very nice examples to the world with their patents, but they didn't make much money out of that, yeah. That's about, yeah, that's right, yeah, that's right. So were the Venetian and Florentine patents an example for the rest of Europe? Probably yes, but not to all countries. The country where I'm really sure is in the Netherlands, because the early Dutch patents were often held by Italian inventors, and that makes me believe they knew the practice in Venice and Florence and brought it to the Netherlands. I hope I haven't overdone too much. Thanks so much for staying alive, staying awake.
Thank you, Peter. Are there any questions for him?
Give me a chance to completely understand you.
What I'm basically saying, the first question is, there is a book which is written in German language, the book that you circulated.
The book about patent history is in German, and I have not been able, sorry for that, I have not been able to convince my publisher to bring out an English translation. I would be inclined to support this, but I haven't found a publisher yet.
Nowadays, computer programs can do that, is that right? Artificial intelligence, they can translate this book in English.
What isn't it?
Well, you have now chat GPT.
Okay. I could do that. Yeah, that's right. Yeah, that's right. But it's still a lot of work. I have translated this.
I have another question.
Let me just finish with that. I have tried that with my novel. Yeah, that was first published in German, and I did the translation into English myself. But it has cost me a lot of time, I can tell you. Yeah? Even if you are looking at Google Translate and DeepL and what all these automatic translation machines do, I put it in, looked at it, and said, well, I must say I've worked for 40 years in US-based companies, so my English is
Very
a
good.
bit acceptable, yeah.
Very good.
And I would say, I look at it and say, an Englishman or an American wouldn't say it this way, yeah. So the automatic translation machines are very good at technical texts. Translating a patent is easy, yeah. But if you get to a thriller or novel or a love story. I have a love story also in my book, yeah. You can forget about it.
I have the second question, which is very important, and that is that at least as I know in 1900, 1901, around that time, the English patent specifically that I know of and I can read has the inventor and the owner of the patent both together in the patent description. When were they separated, and if so, was it which year?
Well, that depends on country to country. Yeah? For example, if you look at British patents, they normally have the applicant or the patent owner in the preamble. But that's unusual. Other patents have it only on the cover page, and the owner of the patent can also change. The only thing that doesn't ever change is the inventor.
No, invention doesn't change, but the ownership of the patent. The owner of the patent and the inventor of the patent are mixed together.
I didn't completely get the question.
What I'm saying is, patent, there is an inventor of that patent, inventor, and then there is an owner of the patent. Are they separated?
Oh, absolutely, absolutely. If I'm employed and working for a company, which I did many years of my life, and if I make an invention, I'm the inventor, but the patent is owned by my employer, because I did it during my office time and was paid by my employer for that, so I'm not the owner of it. There are many legal theories how the rights originate with the inventor. This is in the US, this is still the case. But the inventor is under an obligation to transfer his rights to the employer. And in some countries, this happens automatically. In other countries, you have to have a special legal act for doing that. In Germany, you had, until a couple of years ago, you had even to express a written claim to the invention. They have got rid of that meanwhile, fortunately. Yeah. But this is a question of legal theory. But in essence, inventor and owner are only identical if you have made this invention in your own time, at your own risk, with your own money.
And funded with your own.
Exactly, exactly. We have the microphone. Oh,
I was just wondering if you had any thoughts about the cooking contest of Sybaris in classical times that many people, historians, point to as sort of a proto-patent idea, where the idea first emerges. The cooking contest in Sybaris in Greece, where they had a cooking contest each year, and the winner had the monopoly on making that dish for the entire year, and no one else in the polis could do that. People often just cite that. If you look at popular, if you Google if you Google Wikipedia, you'll see this story.
There are examples, but not from the old times in the 15th and 16th centuries. The most well-known example was in the US, when a competitor of Alexander Graham Bell filed a patent for the telephone 2 hours after Bell had applied. And that was a time when the US Patent Office did not only record the day when a request was filed, but also the time. So Bell won only by 2 hours. But that wouldn't be possible today, because in today's world, the patent offices are only counting days. But I'm not aware of any conflict. I think there was one in Holland. I would have to look that up, involving Christian Huygens, who was a not only a well-known scientist, but also inventor of a pendulum clock. Yeah, right. So, but I would have to look up the details. Yeah. There was at least one more question.
Thank you for your presentation. Do you have any assumption why the first patent of invention was born in Italy and not in any other country in Europe? Are there particular conditions for that, or
Well, I have an easy explanation for Venice, but not for Florence. In Venice, Venice was a republic, and Venice was in a real demand of technical innovation. As I said, dredging canals, operating windmills, raising water and things like that. Yeah. So the funny thing is, there were earlier grants even before the Venetian law was passed. There were Venetian patents that were granted without a law behind them. They will be after Brunelleschi's grant, because Brunelleschi was first, no question about that. But between 1421, when Brunelleschi got his patent, and 1474, when the Venetian law issued, there were a couple of grants that were granted in Venice without any legal basis. But they were still granted. And the law itself was also not always strictly observed, and you can see that with Galilei's grant, which was for 20 years, not 10 years as the law said, and had a fine of 300 ducats, not 100 as the law said. So it was not a very strictly observed law. And there were also a couple of patent lawsuits. One was in, I think it was Verona, yeah? And it was not really clear which authority in Venice was responsible for dealing with this infringement. The law said it was the provveditore, which is some kind of economic authority, but later it was the authority, the water authority, which decided the case. So, and the law said nothing about that. So they took it a bit lightly, I guess, yeah. But now, that was clear. So for Venice, it's pretty clear for me. In other European countries, they were largely, dominated by their kings and yeah, right. And they were not that much interested in protection. Exactly. And
the prince of the king, he gave privilege.
Right.
By appointment of Her Majesty, you get the privilege to do this. So you don't need a patent.
And in Brunelleschi's case, and just 1 second, in Brunelleschi's case, it was surely that he had also very good relations to the Signoria. Yeah. And the patent was only, in earlier cases, what Brunelleschi did, he didn't apply for a patent, but he gave the single parts of his invention to different artisans. You make the gearbox and you make the wheels and blah, 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 blah. So they didn't know how the whole instrument would work together. Yeah? But in the case of the ship, everybody could see it on the Arno. It was a bit difficult. Yeah? So Florence was a bit exceptional, but still they got the first patent in the world. Yeah.
Following the previous question, I'm just wondering, probably there are no examples of patent law of China, where the history of technology is much longer than European history, because there was emperor always and never republic. What do you think of that?
Well, I can tell you the Chinese patent law is essentially a clone of the German patent law. Because when I was educated as a patent attorney, I was assigned to the German patent authorities for the year, and I had some Chinese patent examiners with me in the same course. They spoke some German, yeah, and they had learned that. And China was at the time about to establish its a new patent law. And they cloned it from the Germans, essentially. Like the Japanese have cloned the German civil code. And the rest of Europe has cloned the Code Napoleon, yeah? So everyone was writing from the other. Sorry, it's not a very precise answer, but essentially that's what happened, yeah? That's, for example, why China has utility models, which is something very strange, yeah? Not many people have that. The European Union doesn't have it, but Germany has it.
Okay. Thank you again. And if there are no more questions, I wish we all gather tomorrow in the Antica Canonica, unless, of course, there is some meteor swarm or grasshopper swarm. You know, we have so many difficulties today. So let's see you tomorrow in Piazza San Giovanni 7, 9 o'clock. Thank you again to all the speakers and the attendees.
And thanks again for these many questions at this late hour. Yeah, I'm impressed.